In. So first, thank you to our sponsors. We got a bunch of different sister companies that all contribute to making stuff like this happen. For the class today, first half of the class is mostly lecture. Well, actually, the first class of the class is all lecture. It's kind of like that old Tina Turner song, "Proud Mary." You know, the class starts nice and easy, and then it finishes up nice and rough. So we're going to be doing a lot of hands-on labs when we get into the second half of the class. The best way to go about doing the labs is to download one of the links I'm showing to you on the slides. If you need the slides, go to the ACM webcast content channel. It should be one or two below where we're having the chat and Discord. And you can grab a copy of the slides. You should also grab a copy of the FAQ because that answers most of the questions you might have that you might come up with, like where are the certificates? When will we get certificates? Certificates go out about 24 hours after the class, and again, that's documented in the fact. So yeah, all that stuff is there. But these three links, what's on the VM is the same. I've just made three different versions for three different hypervisors. You know, basically pick your poison. When you want to access the VM, how to access it depends upon, what hypervisor that you're using. With VMware, you can do a direct connect to the IP address. This is the IP address that I assign to it. That should stay by the default. It might change. If it does, I'll show you in a minute how to go through and find the new IP address. And with VirtualBox, port forwarding setup, so you're going to access things through the local host port that got mapped to the port on the VM itself. And I have instructions on that and how it works in a little bit as well. As far as logging in goes, if you're logging in at the console, login name threat, password hunting. If you're logging in with the web browser to the AC Hunter interface, login name is threat@activecountermeasures.com. It has to be an email address. And the password is hunting2, not hunting1, not hunting3. It is hunting2. VMware, common problems. Sometimes I'll see when people go to spin the VM up for the first time, it'll bark about hardware versions. That's really easy to fix. And the instructions are right here. Basically, you just go into compatibility mode and it'll figure out, what's different about your version versus the version that was used to create the VM. And it'll go through and straighten everything out for you. Easy peasy. If it changes the IP address, go into the console, type in the command I showed you here, and it will show you what IP address has been assigned to that VM. That's the IP address you want to connect to. That's the IP address you're going to want to point your web browser at. Generic problems with VMware, it's a resource hog. I tried to minimize the CPU and memory that's set in that VM by default. It did work on my system and another test system, but for some reason on some folks, VMware just gets extra hungry and wants to have more RAM thrown at it. So if you're having problems with VMware, with the VMware VM, I would first try and throw memory at it. And then if that doesn't help, try throwing another vCPU at it. VirtualBox troubleshooting, it tends to work pretty well. I haven't seen it change the IP address that I've assigned to it, but I wanted to include this here as kind of a just in case. If you do change the IP, you may need to go back in and double check the port forwarding setup. I have a link here that'll walk you through how to deal with port forwarding on VirtualBox. Which database do you load the first time you go into AC Hunter? Because it's going to pop up and say, hey, load this database. This is the one you want to go after, DNSCAT 2-JA3. You can go ahead and get started with that. Don't worry if you don't see these other databases listed. We've got a couple of different flavors floating around that have different databases loaded by default. This is the one you want to start with. Everybody should have that. And there was some questions about, we have a couple of online instances running, which is if you can't pull down the VM for whatever reason, maybe you're on a slow link, you haven't started the download yet, and it may not finish in time. We do have a couple of online instances that you can log into. They're documented in the FAQ. Go to Discord, go to the content channel, pull down the FAQ. That'll give you all the instructions you need for being able to connect to those online instances. You are limited in what you can do with them. You can't add safe lists. That's one of the labs that we're going to go through and do. You're not going to be able to delete databases. You're not going to be able to do any of the command line lab stuff that we do. But it'll at least let you work through a good portion of the labs and have access to the AC Hunter interface. The online version does look a little different with some things. Like if you're running a VM, you may see only one system gets listed in a particular lab, whereas the online instance might list a couple. The scoring will be slightly different, and then you might see some other ones listed with the 0 score. Is sorry about that. That was all part of trying to make that instance read only, so that we don't run into a situation where people are nuking things on each other. We've had that in the past where people are trying to share a resource. We ask people, don't delete databases, and inevitably someone has to be a pain and delete databases. So now everybody's waiting for the databases to get rebuilt, and that problem's gone away. How C2 over DNS gets identified. This is the way the modern version of AC Hunter does it. We had to use a backdated version and do the read-only version. It indicated it slightly differently. Again, don't sweat that when we get into the labs, and I'll kind of talk it through. A couple of quick shameless plugs. Bill has an awesome bash scripting class out there. So if you're kind of new to Linux and you want to start working on, how do I automate things? How do I streamline some of the stuff that I'm doing? How do I, go through and write a script to do the repetitive tasks I like to do versus having to do it manually all the time? This would be the class for you. So a link to the class information here, go ahead and jump on that. I've got a couple of them coming up, and some logistics. So top of each hour, we'll do a 10-minute break. At the halfway point of this class, we'll do a 20-minute break. That'll give you a little bit extra time to go through and, water the cat, feed the dog, whatever it is you need to go through and do. But I like to kind of break it up a little bit just so everybody has a chance to go through and get a little bit of a breather. Now, I'm going to be showing some Linux commands, and I'll explain the Linux commands as I go through them. And one of the things you'll see me doing a lot is I'll be using nested commands. So in other words, I'll have a command here, and rather than have the output of that command print to the screen, I'll send it through this little pipe character and then run it through another command. And then I'll send it through a pipe character and maybe run it through another command. I will explain what's going on as we hit each of these. I'll try to make this as easy as possible. But if you're new at this, sometimes it's kind of helpful to go up to explainshell.com, copy, paste that command in there, and they will tell you exactly what's going on in each portion of it. The other thing you can do is you can just try each command one at a time. So in other words, what's the goal that we're trying to accomplish, right? If we're running that command, there's some piece of information we're trying to figure out. Well, run the first command. That'll show you what the output looks like. You'll see, okay, that might give us what we need plus more. And then the second command might remove the stuff that we don't need. And then the third command goes through and sorts and organizes it. So if you run one command and then add the second and then add in the third, seeing how the data progresses and how it gets changed sometimes helps you kind of wrap your brain around this whole thing too. So goals for this class, we're going to talk about cyber threat hunting. I want to have you walk out of here with a really good idea of what's cyber threat hunting, how does it work, and what's the best way to go about doing this. I also want to make sure you have some hands-on lab time. I'm definitely a physical person. I kind of need to do things to have it really sit for me. So like I said, a good portion of the second half of this class is going to be all hands-on labs. But let's start with a basic definition. What is threat hunting? This is still a little open to interpretation. Threat hunting is brand new and different people have different ideas. So please keep in mind that all of this is tainted based on my experience. I've been, working in the computer world since the 80s. Yes, I am that old. And I've been working security since the 90s. So this is, my perspective on this and what works and what doesn't. So, kind of take it that way. But just recognize that if you go to a YouTube channel and they say, oh, threat hunting, yeah, this is what it is. Their definition might vary a little bit. We're still kind of sorting this out. To me, threat hunting is an activity. It's something that you do based on a process timing versus an alert timing. So what I mean by that is threat hunting is an activity that you do every Friday, once a month, once a quarter, maybe once a year. It's something that has a strict schedule defined around how and when, how often you're going to go through and do this. It's not it's not alert driven. So what that means is that this is not reactive. It's more proactive. Hey, we might be compromised. We might not. So I'm going to go through and do a threat hunt today anyway, just to validate that we are still in a good shape. I'm not going to wait to see some obscure alert entry and then decide, well, maybe now's a good time to go through and do a threat hunt. The purpose of a threat hunt, and this is the piece most folks miss. The purpose of a threat hunt is to invalidate the integrity state of everything plugged into the network, not just the desktops, not just the servers. I see some people saying, oh, well, I threat hunt through my EDR software. No, you don't. Because if you're only working with your EDR software, you're only working with the platforms in your environment that's capable of running your EDR software. There's going to be a lot of things left out of that. You're not really doing a threat hunt if you don't include those. I see people saying, oh, well, I threat hunt the logs in my SIM. No, you don't, because not everything generates logs. And even if it does, you can't necessarily count on the integrity of those. Having your system logs be your source of truth has always been kind of a weird concept to me, because you're basically saying, hey, if an attacker breaks into that system and they get full administrative access, I'm going to blindly trust all the log entries that are getting generated by that system. No, that's a bad idea. No, 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 don't do that, please. No, bad dog. No treat for you. Don't do that. That's not a good idea. So our threat hunt needs to be something that incorporates everything on the network, not just the desktops, not just the servers. It's got to include our network gear. It's got to include peripherals like our printers. It needs to include IoT devices. If I have a temp sensor running out the manufacturing floor that's, reporting data to some other physical device, and neither one of those two are capable of really generating logs, there's still a device running software on the network that could potentially be compromised. We need to include those as well. I've seen temperature monitors involved with attacks in the past. There was a news report that came out recently where someone was using toothbrushes to do DDoS attacks. Freaking toothbrushes. Again, my guess is if you have one of those toothbrushes, it's not going to log to your SIM. You're not going to get your EDR software to run on it because it's not running Windows. So what do? You got to start with the network. And that's a lot of what we're going to be focusing on in this class. Are we getting better at detection? In other words, do we even need this? Right? Why threat hunting? We're doing threat hunting because, quite honestly, nothing else we've done has really worked. And this is one of the things that kind of makes me super sad, because we tend to regurgitate the information we've learned in the past without looking at data and just assume nothing changes. In other words, a lot of folks that try and hunt their system logs looking for stuff is because that's what the person who taught them how to do it did. And that's who the person who taught them before them did, and so on back. And no one's looking at, is the data getting any better? In other words, if you look at people who hunt their system logs versus the people who don't, is there a marked improvement that shows hunting your system logs allows you to catch people more frequently? And the answer to that is no. In fact, when you look at how often do system logs lead that local organization to detect that they're in a compromised state, it's about 2% of the time. I want you to think about that. Think about the money and resources that goes into setting up centralized logging and trying to get devices to log to that and manage that thing manage that beast on a regular basis that's collecting all this information. The best numbers out of Verizon and a few others is that it's going to catch one out of every 50 times you get compromised. No, unacceptable. It's not worth that much effort to catch one out of 50. Because quite honestly, it's really hard to make a justifiable business case that, hey, we're going to spend all this money and dedicate all this resource time to a process that'll catch one out of the 50 times that we get compromised. When you look at it like that, you can see that, this just isn't worth it. It's not worth our time. So are we getting better at this? Not really. Some of the data looks a little better, but when you dig into where that data comes from, they're including ransomware. now, right? Ransomware didn't used to be a thing. Now it is. Well, what's ransomware do? Well, ransomware gets into your network. It starts migrating around on your systems. And then, after about 5 to 7 days, it'll go through and it will encrypt all your drives and pop up on your screen and say, hey, pay money to this Bitcoin wallet or you're not going to get your data back. Well, the studies that say we're getting better at this identify that event as a detection. In other words, when the malware says, "Look at me, here I am." Oh, good, you detected it. Wow, that's much improved. It used to take us 90 days to detect this type of thing. You detected it in 7 days. Well, but did you really? No. No. The worst has already occurred. You can't count that. And the analogy I like to use is imagine someone broke into your house last night and stole all of your expensive electronics and then showed up at your door this morning and said, "Hi, I stole all your electronics." Are you going to go on social media and say, "Wow, the cops in my town are awesome"? B&E at my house last night, and the criminal was identified by 8 hours later. No, of course you're not going to do that because the cops had nothing to do with it. This person just showed up. This is the same type of thing. So we need something that's going to get us better than this 90 days, 180 days that we're seeing consistently for advanced persistent threat. And quite honestly, something that's going to find the ransomware stuff before it actually blows up on the network. So so again, to kind of review why is this important? Why is threat hunting important? First of all, you'll see people saying, "I've been threat hunting for 15 years." No, you friggin' haven't, because this hasn't existed that long. You may have been looking at system logs, but that's not threat hunting. You may have been running EDR software, but again, that's not threat hunting. It needs to incorporate everything. And the only way to really do that is on the wire. And the problem we have on the wire is there's a ton of data getting generated. And it's only been over the last 5 or 6 years that we've had the technology required to consume that much data and process it in an effective way to help us figure out when the bad guys are on the network. So if you attend a talk on threat hunting and it starts with the person bragging about themselves and what they've done and how awesome they are, and part of that is I've been doing threat hunting for like 10 plus years. If they give you a number bigger than 5, be really suspect because they probably don't know what they're talking about. The talk's probably going to be more about, you know, hey, I want what I've learned in the past to still be valid. That's really what it's about. So I'm going to try and rebrand myself now as a threat hunter. Yeah, no, it doesn't quite work that way. So, what is the purpose of threat hunting, right? What gap is this filling? What need in the environment? What threat hunting is for is when you look at our existing security tools, they fall into one or two buckets. They either fall into that, this is what we do to keep bad people off our network, or this is what we do once we know the bad people were there. Well, there's an obvious gap between those two, right? How do we figure out that our protections have failed and we need to go into response mode as quickly as possible? That's what threat hunting is for. Threat hunting is there to make the gap between those two time intervals as small as possible. And for the folks that are actually threat hunting on the network now, you know, that gap can be easily dropped to as low as a day, right? Like you're kind of slacking if it takes you more than 24 hours to detect them now with some of the technology we have today. And like I said, this is new territory. A lot of this, quite honestly, comes out of me and the team. We're the ones that have kind of come up with this. We've come out of this based on the threat hunts we've been doing. And oh my God, we've done some doozies. There's been some really wild stuff we've run into. But one of the things we have been able to do is consistently catch everything. I'm reminded of a customer that came in that deployed AC Hunter and then came back to us about 2, 3 days later and said, "Oh, I'm seeing we're seeing this weird traffic pattern on our network. We've got a bunch of devices that are talking to Quanzhou, China." And well, you can probably guess how the start of this conversation went, right? It started with, well, do you have a field office in Quanzhou, China? No. Do you have a vendor? No. Do you have a supplier? No. Then, yeah, this might be something you need to be worried about. And when they ran it down, they found out that the facilities team had purchased a bunch of IP-based cameras off of Amazon, and they came at no additional cost, pre-compromised by the vendor. So they were designed so that once you set them up, they took pictures of your environment and then send them back to, you guessed it, Guangzhou, China. So they paid money to install a bug in their environment. I hate it when that happens. Now, let's go back to what we talked about before. EDR software. Would that be helpful there? No, it doesn't run EDR software. Oh, well, centralized logging. Would that be helpful there? No, absolutely not. Even if it supports some form of logging, it's not going to say taking a picture of your manufacturing environment and sending it off to some Chinese national. Sucks to be you. You're not going to get that log entry. And in fact, these things had been on their network. I think it was like 6 months, 9 months, somewhere in that range there. And it got completely undetected by the other methods they were looking at. But once they started threat hunting their network, they noticed these things were taking pictures and sending them off to, they were communicating back to Guangzhou, China about every 45 minutes, all day long, every day. And each device was doing it. Well, it was that pattern of, hey, every 45 minutes, there's a communication taking place. If I have a system that is in constant communication with a host out on the internet, there better be a business need for that, right? Like, what's a good example of something that might do constant communications where there's a known business need? Well, what about network time protocol, right? That's a great example. My system needs to keep system time or keep an accurate system time. The way it does is it goes out on a regular basis and talks to time servers. Or my system needs to get patched, right? We need to have patches installed so that we don't end up like, ConnectWise and, a perfect 10, threat score, which, oh my God, I've been like involved with that since it started. I don't think I've ever seen a perfect 10 before, but trust me, it's warranted. The attack against their system's pretty bad. But to have your systems checking to see if there's new security patches so they can get installed as quickly as possible, that's a feature. There's a business need for that. So there are some things where our systems might reach out on a regular basis that are okay. And we need to identify those. We need to identify there's a business need with them, normalize them out so they're not part of our threat hunts anymore. But when we see something we don't understand, like IP-based cameras calling out to Guangzhou, China, that needs to set off a red alert to say this is something we need to go in and pay attention to. So a lot of what we teach in this class is based around those types of things, being able to detect that type of activity. And really the core of this is starting on the network. Because again, EDR software doesn't run on everything. Centralized log collection, even if you think you're collecting logs from everything, you're not. Again, I've been doing this since the 90s. I have yet to see a single environment where they do actually collect log entries from everything. I've seen plenty of environments who thought they were, and we were always able to identify things that were missing. But for a threat hunt, we need to see everything. And neither one of those are ever going to give it to us. Well, think about the network, right? If that system's compromised and it's calling home, it's going to take place over the network. So if we monitor the network, we'll see that. And it doesn't matter if it's an IP-based camera, a Windows box, or an old Atari 7800. We're going to see that command and control going out so that the attacker can do what they want to on that box. So by targeting that command and control channel, we can follow one process. In other words, the same way I'll figure out if that's a legitimate business need or if it's a command and control server on a Windows system, a Mac system, a Linux system, a BSD system, a Cisco router, run down that list. Every single one of those devices, the process I will use to figure out if that's a legitimate business need connection or not is exactly the same. Truth be told, I don't care what the platform is unless I suspect that it's in a compromised state. Now the platform will matter. But up until that, the way I'm hunting is going to be the same for everything. And I'm going to see everything. Because again, that command and control channel needs to be able to call out. So if we go after that, we're going to be in much better shape. So someone picked up on, I mentioned Atari 7800. Yeah, that's always one of my favorites. I always like to see who's as old as me because they will know, yeah, no, there was no internet cartridge for the Atari. That wasn't an option. There was no online gameplay or anything like that. But when I do pen testing, or when I run stuff through examples, I tend to use Atari 7800s as my user agent string. Just because if I see that on the network, I know it's nobody else but me, right? Like if I try to emulate like Windows 7, with the Internet Explorer version 7 or something weird like that, as rare as it might be, I might actually run into people who are legitimately still using those software packages. But Atari 7800, that's always going to be just me. All right. So let's talk about. So we've kind of framed why we need threat hunting. We've framed what purpose does it serve. Now let's kind of talk about the process from a high level perspective. In other words, I want to run through what's the entire process of so how would I explain the threat hunting process to your boss so that they kind of get an idea of what all the steps are? And then we'll pull back and then we'll start jumping into more detail in each of these steps. So the first thing I would need to be able to do is I need to be able to monitor my internal systems talking to the internet. Well, that's fairly straightforward, right? Where are they connecting to the internet? Monitor there. So, a common point of monitoring is usually the internal interface of the firewall, because that's going to see all the pre-NAT data. I might use a network tap. I might use a spam port on my switch, but I plug in some way to be able to see all the traffic going in and out of that internal interface on the firewall. Once I see that, I'm now seeing all the traffic headed to the internet and all the replies that are coming back in. Once I can see that, now I go looking for persistency. Somebody connects to an IP, talks to it for 5 minutes, and then does do it again for the rest of the day. Probably not going to worry about that. But I'm seeing a connection going off once per minute. I'm seeing a connection going off. Let's see. uh, what's a good one? Oh, I know. Sunburst. There's one that most people missed until FireEye made an announcement. Sunburst was going off every 15 minutes plus or minus a minute and a half, right? So the dwell time between connections might be as short as 13 and a half minutes. It might be as long as 16 and a half, but it was doing it at that pattern all day long, 24 hours a day. So we want to look for that type of connection persistency. Or it might just be it connects to a system and just leaves that connection open all the time. It doesn't disconnect, it just leaves the connection open. That's another good example of persistency. Once we identify persistency, now we need to go in and take a look at, is there a business need for this? Is there a legitimate reason for this to be here? Like I said, network time protocol, installing patches, there may be legitimate reasons why, a persistent connection is needed. And if we see that, great. We say, yep, there's a business need for this. This is okay. So we can go through and we can identify that type of connectivity is something that we can basically ignore in the threat hunts that we do going forward. We'll talk about safe listing and how that works a little bit later. Some of these might take a little bit of research. I'll give you a great example. TeamViewer. TeamViewer is remote access software. Whether that's good or evil kind of depends on whether you know TeamViewer is installed on that system, right? I have been on threat hunts where we've gone into actually this one was a hospital that we went into. And one of the pre-qual questions we ask is, do you run TeamViewer? And the answer was yes. We have TeamViewer running on, I think they identified 2 or 3 systems. And we went in and we found TeamViewer running on like 15 different systems. Well, in that case, TeamViewer on 3 systems, good. It's a feature. We know it's there. No problem. TeamViewer on the other 12, bad. How did TeamViewer get there? Why is it there? This is something we now need to go and run down. So some of these are not always 100% cut and dry. Sometimes they need a little bit of context from the inside environment to figure out what's going on. I saw a thing in Discord. What advantage would AC Hunter offer over analyzing firewall logs? Steve, firewall logs are freaking horrible for this. Firewall logs, 2 problems you run into. One is they don't give you connection duration. In other words, if I create a connection to a system out on the internet and I leave it open all the time, the firewall isn't going to tell you that. It will tell you when the connection started. It doesn't tell you when, if ever, the connection actually ended. So you're not going to be able to identify that type of persistency. The other thing you run into a lot with firewall logs is rate limiting. So if someone connects to a system, let's say once per second, the firewall vendor may have decided, oh, that's just going to fill up the logs. So we'll only log it after when we see that connection, we won't log it again for like another 30 seconds. So you might not get proper visibility as to what's going on either. So there's a lot of reasons why I've tried threat hunting with firewall logs, and it's not necessarily the easiest way to go about doing it. And I'll dig into that more as we get into, short answer for now. It's not so much about AC Hunter really as it is about Zeke, the tool we use to collect the data. And I'll get into that more a little bit later. So identify connection persistency, identify if there's a business need. If there is a business need, safe list it. If there's not a business need, okay, let's start digging into this a little bit deeper. Let's look at the protocol. Is there anything weird about the protocol? Usually, when attackers are creating a connection back to a command and control server, there's usually something a little off about that connection, right? Like, hey, that system normally identifies itself as being Windows 10. But when it connects to this one IP address out on the internet, all of a sudden it thinks it's Windows XP. Well, that's weird, right? The systems don't usually do that. So we want to go looking for that type of abnormal behavior that's taking place. We may want to do some investigation work on that external host that they're talking to. We may want to do some investigation work on the internal host. Once we've gone through those steps, we need to be at a spot where we can make one of two possible dispositions. Either I'm pretty sure that system's in a compromised state. We need to jump into incident response mode, or I'm pretty certain there's a legitimate business need for this and this is okay, in which case we go through and we add it to a safe list. One of the cool things about threat hunting is that when you do it right, it's a self-improving process. In other words, let's say I've got a 1 gig connection to the internet and I go through and I do a threat hunt. The first threat hunt I do might take me 2 days. But if I'm properly creating safe list entries, the next hunt is probably going to take me 1/4 of that amount of time. The next time I threat hunt after that will take me half the amount of time that the quarter took. In other words, it's self-improving. These hunts take less and less time as you go through until you eventually get to a spot where you can say, okay, I'm pretty confident in everything on my network. So now the only thing I'm going to do is worry about changes. I'll still do I'll drop from doing like a weekly threat hunt to doing a quarterly threat hunt, but I'm also in a state now where I can say, where if I can identify new persistent connections, I'm going to go in and jump in on those right away. So the concept is start with the network. Let me kind of describe what we're looking at here. We've got an internal IP private address talking to an IP address out on the internet. We've got some information about this host that's out on the internet here. This is telling us that the ASN, that section of the network, has been allocated to DigitalOcean. They're a public cloud provider. It gives us some geolocation information about where this particular data center is located. This one's kind of interesting to me. This is looking at what did the user query via DNS that brought them to this IP address. And what this is telling us was there were no DNS queries that took place that came back with this IP address as an answer. Ooh, that's kind of odd. Someone's not using our normal DNS process to connect to this. Something else is going on. That makes me, that doesn't automatically mean it's a threat, but that's definitely, building in a little bit more suspicion on what's going on here. See this graph on the bottom? This is a graph over time. So what this is describing is my x-axis is time, each bar is 1 hour. My y-axis is quantity. So this is describing how many times each hour this IP address created a connection to that IP address. Notice I can pretty much draw a flat line across the top of the whole thing. Anytime I can do that, that's connection persistency. We're connecting out on a regular basis. There needs to be a business need for this if we're talking to somebody this often, right? If there's not, then we need to be a little bit nervous about what might be taking place here. This graph here is also kind of interesting. So this is still looking at dwell time, but it breaks the data out slightly differently. What this is looking at is, hey, when this IP address connected to that IP address, how many seconds went by between those connection requests? So in other words, if if it was 60 seconds, right? If I connected and then 60 seconds later connected again, and I was repeating that pattern over and over again, I would see one bar here and one bar only at the 60-second interval. But here I'm seeing a couple of different time intervals that are close to each other that are being selected. This is what's referred to as jitter. I'll talk about this more later and what it is and how it works. The short answer for now is that jitter is used by attackers to try and hide the fact that this is a command and control channel. There's math algorithms that folks like to use that get fooled by this. So because of that, they jitter their connection a little bit. This this attribute of this being a bell curve tells me this is somebody running Cobalt Strike. Cobalt Strike, when you run Cobalt Strike for your command and control channel, right, and red teamers use this, the bad guys use this. Everybody loves to use Cobalt Strike. I think about 95% of what I see out there that turns out to be something suspect ends up being somebody running Cobalt Strike, whether it be, again, a hired red teamer or somebody who's doing evil. Um, Cobalt Strike allows you to go in and pick a time interval and then pick a variance off of that. So I can go in and I can say, hey, I want to beacon, I don't know, I want to beacon once per minute plus or minus 50%, right? Well, now the beacon interval might be as short as 30 seconds, or it might be as long as 90 seconds, right? It's that 60, take 50% of that, and then make that your plus or minus. That's how it works. Because Cobalt Strike isn't as random as it thinks it is, it ends up picking more time intervals closer to the mean than it does the min or the max. And the result of that is what you see here. You get a little bell curve out of the whole thing. So I'm looking at this saying, okay, I don't know where they were trying to go, but this really looks like C2 for me. Now, I kind of poo-pooed on system logs earlier. They're not useless as part of a threat hunt. They are not, absolutely not where you want to start, but they can certainly supply supporting data. One of the free projects that we support is a project called Beaker. And Beaker is wicked cool. Because what Beaker does is Beaker leverages Microsoft's Sysmon utility to monitor applications that talk on the network. So we don't look at everything the box is doing, permission changes and, registry key changes. And, that's just noise. At the end of the day, what you really care about is apps on the network. Because if somebody breaks into that box remotely, it's over the network. They set up a command and control channel, it's over the network. Right? If they get into a system and they try and move laterally, you guessed it, it's over the network. So what Beaker does is it monitors what applications are talking on the network and who are they talking to. So when I see something like this, now I can maybe leverage my system logs to be able to see something like this. So this is saying, oh, when that IP address was talking to that IP address over the time frame that was being analyzed within the AC Hunter interface, Runtime Broker was responsible for initiating those connections. Oh, okay, it's Runtime Broker. What's Runtime Broker? Oh, Runtime Broker is a tool that enforces the permissions of applications you've downloaded from the Microsoft Store. So this is a feature, right? It secures applications that were brought down and make sure they stay in their sandbox and don't try and break out. Oh, well, wait a minute. If it's Runtime Broker, why is it connecting to DigitalOcean? Wouldn't it be connecting to Azure? That doesn't make any sense. And oh, wait, why would Runtime Broker need to be connecting out at all? It's checking local permissions. There's a profile that identifies what that app should have access to and what it shouldn't. It doesn't need to talk to anybody to figure out if it's trying to break out of that sandbox. This may not be the Runtime Broker we think it is. So again, if I was just going through system logs and saw Runtime Broker, I would read about how this is good. It enforces permissions on applications. Yay, I like it. But in this context, we can see it's clearly not the Runtime Broker we think it is. Again, start on the network, pivot into the host logs as needed. This is a much better process for going through this stuff. You'd never want to write a signature. You might write a signature that says, oh, hey, if somebody runs PowerShell, tell me about it. Okay, that makes sense. If one of the local security or IT people are running PowerShell, probably not a big deal. But if Bob in sales is running PowerShell, Bob in sales doesn't use PowerShell, right? Not on purpose. So that may give us a big red clue. Well, I'm not going to do the same type of thing with Runtime Broker, though, right? Because that may be running on every system. I'd see a crap load of false positives out of that. But here we have context, right? Here we have the context of it's creating connections on a regular basis. It's not behaving like the application should. This is probably not the application we think it is. Makes it a whole lot easier to run down. One of my big rules, don't cross the passive active line. What do I mean by that? I mean that what you do as part of a threat hunt should be totally invisible to anybody who may have potentially compromised one or more of your internal systems. In other words, if you see a box acting suspiciously and you go log into that box and you open a command prompt and you start typing in commands, you've broken that passive active line. You've started performing activity that can tip off the attacker that you may be onto them. Threat hunting should not include that. That should be part of your incident response process. Why? Because you've just chose to give up to the attacker. Hey, look, I'm coming after you. And now might not be the best time to do that. There may be more data that could be collected. With threat hunting, we tend to kind of do that in a bubble, right? I'm a threat hunter, I'm doing my hunt. If it's incident response, though, incident response tends to pull together a lot of different disciplines all at the same time. And we tend to be less likely to shoot ourselves in the foot. I'll give you a great example of that. One of the things I see a lot is when folks go in and they say, oh, the system's been compromised. The first thing they do is they isolate that system. Kind of makes sense, right? Oh, I know it's in a compromised state. I'm going to isolate it off of my network. It seems logical, right? Here's the problem. You've now done something the attacker can detect. What if they don't own just that system? What if they own 10 other systems too? Well, now you've let them know you're onto them. They can still come in over 9 or 10 other boxes. Now that they know you're catching on to them, they may decide to start going scorched earth on your environment. Let's trash things as much as possible to distract you so you're less likely to catch on to them and what they're actually doing. In other words, they now that they have intel that you're onto them, they may start changing up their tactics in a way that's going to make your life miserable. Now, as a threat hunter, you by yourself, you may look at that and say, oh, compromised system, isolate it off, and it might make perfect sense. But if you get an incident response team together, one of the forensics people might say, whoa, wait, before we isolate that box, let's do a check to see if anybody else is talking to that same command and control server. Because if they are, they're probably compromised too, and they need to be part of that scope. So there's lots of little gotchas like that that you're far more likely to keep from shooting yourself in the foot with if you pull together a team of people. Thus the whole don't cross that passive active line. If it's time to cross the active line, it's because you're in incident response mode, not because you're doing a threat hunt. All right, let's talk about some techniques. So we're talking about monitoring the network. How much data do we need off of the network? You can try and do this with as little as you want, but quite honestly, you really need 12 hours or more. What I recommend to folks today is, based on what's going on with like nation state stuff, you want a 24-hour block of data. Without that, you may not get the visibility you need. Most commercial tools use a 20-minute window, right? So I mentioned Sunburst earlier. I mentioned most people miss that. Some of the people who missed that were running commercial grade threat hunting tools. The reason they missed it is because those tools use 20 minutes or less of network data to figure out what's a persistent connection and what's not. Sunburst was going off once every 15 minutes, plus or minus a minute and a half. So if I'm working with 20 minutes of data, that means that I will see one, maybe two connections from that Sunburst server. Well, it's not really enough to figure out it's a persistent connection, right? Two connections? Come on. If I say two connections is threshold for persistency, I'm going to have a crap load of false positives to go through. So 20 minutes just doesn't cut it. But if I spread that out to 24 hours, well, now I've got almost 100 data points to work with, and I have a 24-hour period to work with to see if those close to 100 data points are evenly spread out in the course of the day. Well, that gives me plenty to work with to be able to go in and tag Sunburst. So again, the more data we have to work with, the better off we are. The challenge is for a lot of networks, 24 hours is a lot of data. So how are we going to process that? So where to deploy this? I talked about this. Typically, what we want to do is we want to have something capturing traffic off the internal interface of the firewall. My tool of choice is Zeke. Zeke, quite honestly, is one of my favorite threat hunting tools. Now, you know, caveat here, I do work for Active Countermeasures. We do make an open source, a community edition, and a commercial edition of a threat hunting tool. I am product owner for those. By rights, those should be my favorite. But I honestly have to say Zeke's my favorite because we couldn't do what we do without Zeke collecting the data that it does. I see a lot of folks that say, well, we'll go in and, we'll use some Cisco protocol that gives us summary information, and that doesn't work as well. You're not getting the same resolution that you get out of Zeke. I'll talk more about Zeke as we go through. But like I said, the goal here is to be able to look at all the traffic going in and out of our internet link. So wherever it makes sense to be able to go in and take that, we're going to be in better shape. We want something with decent resolution. So something like NetFlow that summarizes the data that gives a minimal amount of information possible is probably fine for dealing with things like scaling, right? Performance scaling. But when you start getting into threat hunting, where you need a decent amount of application data to get this to work right, NetFlow doesn't give you any of that application data. It's absolutely useless for that type of thing. Does targeting C2 have blind spots? Yeah, nothing's perfect. Right? Don't get me wrong. I'm not saying this is the magic bullet that will, do your laundry and make you a perfect cup of coffee in the morning and, solve every problem that you ever run into and make sure your kids do the homework, you do their homework. And no, nothing's perfect. There are variations of malware that don't bother setting up a command and control channel. They don't happen that often, but they have existed. The original Morris worm was malware that didn't create a C2 channel. Not Petya was one that didn't create a C2 channel. The problem with tools that don't create C2 channels is that they tend to get out of hand and have a much bigger impact than the original programmers expected. So, for example, with NotPetya, right? NotPetya was Russia targeting Ukraine. And what they did is they did a supply chain attack against one of the tax software vendors, the biggest one in Ukraine, and they got their malware distributed that way. So you thought you were getting tax info, you were actually getting malware. And their thought process was, well, this is attacking Ukraine. It's going after people who pay taxes in Ukraine. This will be anybody doing business in Ukraine. So we don't need a C2 channel. It'll just nuke all their systems and we'll be fine. Well, you know where this is going, right? There are global companies that do business in Ukraine, but also do business in Russia. And now all of a sudden, this thing was starting to propagate itself back into Russia again, and they hate it when that happens. It also did things like shut down global shipping. So even if it wasn't a Russian company that was getting compromised, it was an international company that Russia was trying to sell goods either to or buy goods from or try and contract to be able to transport those goods in or out. And all of them were getting shut down. So it it's kind of funny in a way because when you look at what happened with NotPetya, Russia arguably had a bigger financial impact to this malware that they wrote than the country they actually targeted with it. So that's why we don't tend to see these types of attacks that often. So like I said, start by checking consistency. And part of that is we're going to see is there some sort of identifiable business need. When we talk about connection persistency, what do we mean? There's a couple of different flavors that this can come in. The easiest is long connections. A long connection is just simply connect to that IP address out on the internet, hold it open all the time. And like I said, one of the reasons why this tends to fly under the radar is because firewalls log the initial connection attempt, but they don't tell you when the connection closed. So you don't see the duration that's associated with that connection. So I can connect out to an IP address once. You see one connection only, but I could be holding that open 24 hours a day. Microsoft does that a lot these days, and most sites don't even realize it because it'll do one connection when that system first boots up and just leave that connection open all the time. Windows notification services is a great example of that. Your Windows box will call out to Microsoft and just hold that connection open until the next time you reboot it. So these can be kind of challenging to go through and find. It's also, you could look at this from like a cumulative perspective, right? So we've seen, oh, which one was it? Now I'm forgetting the tool that was actually doing this, but what they were doing is they were going in and they were saying, connect back to the command and control server, hold that connection open for 15 minutes, and Metasploit. That's what was doing this. Connect back, hold the connection open for 30 minutes, close the connection, immediately reestablish it again. And that one was honestly really sneaky if you think about it, because it's connecting every 30 minutes. Well, if I'm checking a 24-hour block of data, that means there's less than 50 connections in a day. So if I'm looking for a system that's connecting thousands of times per day, 50 is way, way buried in the noise. I'll never pay attention to that. If I'm only holding the connection open for 30 minutes, that's not a really long duration of time. So typically, if we go looking for long connections, we want to see things that have been connected for like 5.5 hours or more. Something that looks like it's at least staying open for the entire business day type of thing. So 5.5 hours and above is a good one to go after. Well, they're only holding the connection open for 30 minutes. That's again way down in the noise below 5.5 hours. So you're probably going to miss that. So to catch something like Metasploit, you also have to look at long connections from a cumulative perspective. How many, out of the last 24 hours, how long were these two systems in communication with each other for? And when you look at Metasploit in that context, every 30 minutes it's killing the connection but reestablishing it again. So that's 24 hours worth of communications in a 24-hour period of time. So we can look at long connections as a single connection or cumulative communication time. Either one of them is valid. One of the um, so like I said, Zeke is one of my favorite tools, but Zeke isn't perfect. One of the challenges you run into with Zeke is Zeke doesn't log a connection until it closes. Well, this is a problem. What if malware calls home and leaves that connection open for 90 days? Well, now you won't get a log entry out of Zeke until after 90 days. And then you'll see the duration was 90 days. And you might look at that and say, whoa, wait a minute. I check my Zeke logs every day. Why am I only finding out about this now? And it's because it doesn't log anything till it closes. We actually have a plugin we created for Zeke. It's up on our GitHub that you can pull down. Or if you install Rita or AC Hunter, we automatically modify your version of Zeke to include this. But what we do is once an hour, we go look at the state table, right? Zeke maintains a state table of all the connections it's seeing. And we say, okay, out of all these state table entries, what hasn't been written out to a log yet? And for the ones that haven't been written out to a log yet, we create a brand new log entry called open dash connections, and we write those out to those as well. And what's nice about that is, so let's go back to that 90-day example. After 2 hours, you'd see the connection was open for 2 hours. And then an hour later, you'd see it's been open for 3, and then 4, and then 5, and then so on. And it will just keep increasing and increasing each hour that you check the data. So you see it as it grows. You're not waiting until after 90 days to be able to go in and see that. So that's a long connection. Another way of doing communications is a beacon. And this is the one I kind of described earlier. With a beacon, I create a brand new connection to a system. I exchange whatever information I need to at the time, and then I close that connection. And if I need to talk to that system again, I just reconnect to it. So that's that repetitive connection. My target, who I'm talking to, could be an IP address. It could be a fully qualified domain name. And I'll get into this more when we come back from our first break. But one of the savvy things that attackers are doing these days is they're taking their command and control servers and they're putting them behind content delivery networks. Well, that makes them so much harder to detect because now it's not just you're beaconing out to a single IP address in Guangzhou, China. Now it's you're talking to the CDN network over in Amazon or Akamai, and there's legitimate traffic going there as well as this malicious traffic. So it's hard to tell the difference between the two. And it's not just talking to one IP address, it's talking to 12. How do you figure out persistency around that? So we'll kind of talk about solving that when we come back. But the whole idea is it's a source talking to a target, and they're doing it on a repetitive basis. And I tell you what, we're coming up at the top of the hour. Actually, I can get through this in 2 minutes, no problem. So this is your classic command and control channel. So the attacker gets malware delivered to this internal system. Let's assume phishing attack. My user clicks something they shouldn't have. The attacker's done their homework and they figure out how to get this thing to load without my EDR software tagging it. The first thing it does is it starts calling out to a command and control server. Why? Why doesn't the attacker just manage the malware? Well, I got a firewall here. This is a private address. They can't connect to it directly. So they need to install a proxy or a middleman in order to broker the conversation between the attacker and the compromised system. So this compromised system will now start checking with that command and control server on a regular basis, saying, do you have anything for me to do? No? Okay, I'll go back to sleep. Hey, do you have anything for me to do? No? Okay, I'll go back to sleep. Hey, do you have anything for me to do? No? Okay, I'll go back to sleep. It just does that over and over again. Now my attacker logs into the command and control server and says, hey, I want this system to run the task list command. Well, now the next time this system calls in and calls home and says, hey, do you have anything for me to do? Yes, run the task list command. Okay, the malware runs the task list command, takes the output from running the task list command, exfiltrates that data out to the command and control server, and now the attacker has access to it. So again, the command and control server is basically a proxy or a middleman, if you will, between the attacker and the systems that the attacker is compromised. All right, with that said, we are at the top of the hour. So we're going to do a 10-minute break. This will be a quick one. And then when we come back, we'll hit it from here. There's folks helping out in the Discord channel if you need help. All right, we are back. So when we left, we were talking about command and control. And I was talking about its basic operations. There's some variations off of this that we'll get into in just a little bit. But the basic premise is the compromised system calls out to what we refer to as a command and control server. And that command and control server is really acting as a proxy between the compromised system and the actual attacker. The attacker can log into the command and control server. They can queue up commands that they want to run on the compromised system. And as that compromised system checks in to see, hey, do you have anything for me to do? It then goes through, executes those commands, and exfiltrates that data back out again as part of the same command and control server. So, from an attacker's perspective, this is a very efficient way to control this system. Now, I also mentioned that attackers are getting a little bit smarter because for the folks that monitor what their systems are talking to, you may notice, hey, I have a system talking to an IP address in Guangzhou, China. That doesn't usually happen. Let me go and run this one down. Well, the new technique is take the command and control server and put it behind a content delivery network, a common one that's going to be used by legitimate businesses. And I used, Akamai and Amazon as two examples. And I use those two examples because those are the two that we've run into so far that attackers have been hiding malicious code behind. So now what happens is when this compromised system goes to call out, they're calling out to this fully qualified domain name, foo.evil.com, just an example. Don't go writing a signature for it or anything weird like that. But that actually resolves to multiple content delivery networks. So now rather than having my IP talking to a single IP, it's talking to multiple IPs. So that repetition of signal that I talked about isn't quite as obvious because it's going to be spread out over, this is showing it talking to 3 IPs. But a lot of times when you're talking to CDNs, there may be a dozen or more different IP addresses you're talking to. I've seen as many as 20. Further, it's not just the malicious traffic talking to those CDNs. In the case of Akamai, Microsoft uses Akamai for CDN services. So it may be Windows calling home for normal, regular Microsoft traffic. It might be a compromised channel. So now it's spread out over multiple IPs and there's legitimate traffic mixed in with it as well. So we can't go looking for beacons from IP address to IP address anymore. We have to look for our beacons going from our source IP address to the fully qualified domain name that they're trying to talk to. In other words, we need to be able to kind of see what are they trying to get to on the other side. Now, there's a couple of ways we can go about detecting beacons. The most common is to do it based on timing, and I've already talked about that. I talked about sunburst. It goes off every 15 minutes, plus or minus a minute and a half. That's detecting the beacon based on the timing interval that it's using. I mentioned that plus or minus a minute and a half was a technique referred to as jitter. An awful lot of the commercial threat hunting tools that are out there today use k-means clustering to detect beacons. K-means is, quite honestly, it's just simply a math algorithm. It's designed to find repetitive patterns in large data sets. So imagine you had 1,000 connections go out to the internet yesterday, right? Or excuse me, let's say make it bigger. Let's say a million. You had a million connections go out to the internet yesterday. But buried in there is one connection from an internal system talking to an external IP once per minute, every minute, all day long. Well, that's a repetitive pattern. K-means will look at that and say, hey, you may want to go in and pay attention to that. But if the connection's jittered, if it's once per minute plus or minus 50%, well, now my dwell time might be as short as 30 seconds, it might be as long as 90. That's not a repetitive pattern anymore. K-means won't detect that. And the dirty little secret in this whole thing is that any vendor relying on K-means clustering to find beacons, anything that jitters, they need to fall back on using a signature. So now we can't find new cutting edge attacks anymore. We're back to signature based. We can only find the stuff that we've known about and has been around for a while. Well, that blinds us horribly because attackers are innovating all the time. We can't count on them. We can't say, oh, well, they did this 5 years ago. They'll keep doing it now. No, they're constantly innovating. We need to keep up. And signature based just does not do that by any stretch of the imagination. That's why we moved away from it. The other challenge you run into is, per the last slide, a lot of this stuff is going through content delivery networks. So if you're looking for repetitive patterns, it may be spreading it out over 12 or 20 different IP addresses. You're not going to see that pattern. So again, K-means is dead, quite honestly. How often is jitter used? I have not seen a red teamer or a malicious actor not use jitter in at least 3, maybe 4 years now. I haven't seen a persistent signal done by an attacker in the wild in at least 3 or 4 years. So K-means is kind of dead. And I talked about this. I talked about, hey, if we've got a large data set, we can go through and we can normalize out each hour and then look to see if there's a repetitive pattern hour to hour. And that's kind of what we're doing here. So again, each of my bars represents a 1 hour period of time. My y-axis is quantity, how many connections took place each hour. And I said, anytime I can draw a flat line across the top or I can come close to running a flat line, because it might not be exact. Again, we're jittering, right? So what's going to happen so again, let's use that simple example of once per minute plus or minus 50%. And what we're going to get is about every time a 30-second time interval is selected, we'll also get a 90-second interval selected. Well, add those up, divide by 2, you come out with 60, right? So that they normalize each other out, but it's never perfect. So I might normalize out to, 60 1 hour. And then the next one, it might be 63. And then the next one after that, it's 58. So, these lines, and you can see this here, the lines might not line up exactly flat. That's okay. It's pretty damn close. If I can pretty much draw a flat line. Now, at the beginning, we had a drop off at the start. Okay, this might just mean they started halfway through the hour. And then we see it was kind of high and then it slowed down a little bit. But for a majority of my time interval, again, I got a flat line here. That's persistency. That's something we need to go in and take a look at. So, like I said, a connection without jitter, if I look at it from what dwell times am I seeing, they're going to look something like this, where everything's going off at the same time interval. My experience, so it's still worth investigating. But when I see something without jitter, I tend to get a little less nervous these days because most legitimate applications don't jitter their timing, right? So, like we mentioned network time protocol. So, network time protocol goes off every 15 minutes, 20 minutes, or 30 minutes, depending upon what operating system you're using. But it's always that interval. If it's 15 minutes, it is always exactly at the 15-minute interval every single time. So when I don't see any jitter, I still want to investigate it. I still want to make sure, but I get a little less nervous. If I'm seeing jitter, yeah, I get a little more nervous. The only time I've seen jitter being used legitimately in the wild is in public cloud environments, right? The cloud vendor will set up monitoring on each of those VMs, and they don't want to get into a situation where every VM reports at exactly the same time. So they jitter the polling interval just a little bit as they go through. But those tend to be obvious, right? Like you'll be in the Amazon environment and you will see it's jittering to another Amazon address that's very close subnet wise. Okay, that's just Amazon monitoring their instances. That one's not a big deal. I mentioned Cobalt Strike, but you may see others on occasion. I have on occasion been pleasantly surprised that folks have put time and effort into trying to randomize their jitter as much as they can. This is probably an example of that. I can see I've got jitter going from as short as 5 second interval all the way up to like 46 second interval. It's kind of heavy loaded on the top end. This is certainly a lot more random than this. But whatever techniques we use, we need to make sure that even if they are doing a good job of randomizing that jitter, we can still detect it. And again, one of the easiest ways to do that is to just normalize these out once an hour and then look for our pattern based on an hour per hour basis. The only real challenge with that is that's a lot of data. Now, we can also look for beacons based on session size. When a compromised system calls home, I mentioned it checks in and says, "Hi, I'm here. Do you have anything for me to do?" There's some command associated with that, right? When it connects up to the command and control server, there's some commanded issues that's basically the equivalent of it saying, "Hey, I'm here. I'm compromised. Do you have anything for me to do?" Well, it's sending that command every single time. So as long as there's no command sitting in queue, that's going to result in the same session size each time. Well, Chris, couldn't they jitter session size? Yes, they could. I have not seen that yet in the wild. We've already started building in detection for it when the attackers eventually get around to it. One of the things we're always doing is we're looking at what might attackers do next. Let's make sure we can detect that today. We kind of ran into that with the CDN network thing. We had already built into our tool the ability to detect command and control servers sitting on the other side of CDNs so that when it happened, we were able to see it right away. Whereas, some other folks are scrambling to try and figure out how to deal with that one. We had already got that done. We've done that here with the session size. But with that said, I have not seen red teamers or malicious actors jittering their session size yet. So we still have that as a technique we can leverage for now until they change their ways. But like I said, every time it checks in, and there's no commands for it to do. And if I have a fairly short time interval, like it's checking in every 10 seconds, every 30 seconds, majority of those connections in the course of the day are going to be, nope, I've got nothing for you to do. Go back to sleep. I'm going to see a consistent session size going by. That's something I can go in and key in on. That's what we refer to as the heartbeat. So the heartbeat is just that, hey, it's checking in and there's nothing for it to do. Hey, it's checking in and there's nothing for it to do. What might change that session size? Having something to do, right? It checks in. It says, "Hey, do you have anything for me to do?" Yes, run the task list command. Okay, I will run the task list command, take the output from that task list command, and send that out to the command and control server. That's going to change the amount of data that passes over that session. So, one of the really cool things about session size analysis, you can figure out how often has the C2 channel been activated. You can figure out how much data has been exfiltrated. And oh, by the way, we don't need to decode anything. In other words, if they're using TLS encryption, we don't need to put a proxy on the network and decrypt all that TLS to figure out what's going on. The session sizes going by is enough to figure that out. And in fact, quite honestly, there's a number of vendors that ship boxes that are, they call them like proxy interceptors, and they, try to give them some really cool names to get you to spend more money on them. But the whole concept is the compromised system, when it calls out, if it's doing it using, let's say, TLS encryption, this proxy interceptor will decrypt the TLS, look at what's inside, and let you know if it's C2 or not. And if it's not, then it'll let it go through and pass it through on the other side. The concept is sound. Here's the implementation problem. The implementation problem is attackers, for at least the last 3 or 4 years now, double encrypt their data. They do some level of obfuscation. Even if they don't encrypt, they do some level of obfuscation, and then they pass it through a TLS channel. So they may go through and take their data and convert it to base 64 and then zip it and then send it through a TLS channel. Well, think about that. So now I've got an intercept proxy, and it strips off the TLS channel, and it does pattern matching to look for the task list command being run. Is it going to see it? No, not going to see it, because it's base 64 and then it's zipped. Or if the attacker is, nation state level, it may be AES 256 encrypted. No, it's not going to see task list. Well, then what good are those boxes, Chris? They're not. They're a money suck. It was kind of funny because I was at a conference where there was a vendor pushing one of these boxes, and we talked about hey, attackers are encrypting the data before they throw it down a TLS tunnel, and they said, yeah, we've been seeing that too. Well, if you've been seeing that too, then this doesn't work. Why are you doing this? Oh no, this gets you closer to the data. You're taking off that TLS layer of encryption. No, that's not how encryption works, right? Encryption is not like a blurry set of binoculars, right? Where, oh, if I wipe one lens, I can see a little better. No, no, no. It's you take off TLS, and what's there is still ciphertext. You can't do anything with that unless you can strip away that encryption layer as well. So they're basically selling these boxes that they know are useless, but customers are giving them money for it. So, hey, what the hell? Let's just keep doing that. So trying to strip off TLS to find this stuff, to try and pattern match on stuff, doesn't work. But session size analysis, you can pull some interesting information about that. I'll give you a good example, right? So imagine we've got a compromised system. There's a 1 gig database on this box, and it's got all our customers' private information. There's social security numbers in there. We have credit cards, who's their firstborn male child. I mean, it's got PII up the wazoo within this database, and this box gets whacked. And we see the command and control channel coming out of it. And our boss comes up to us and says, did they get the database? Yes or no? Here's your data to work with. Is the answer to that question yes or no? No, right? Well, wait a minute, Chris. How do you know they didn't get the database? Look at our sizes down here, right? My heartbeat, do you have anything for me to do? No, go back to sleep. The amount of data that's getting transferred as part of that is about 90 bytes, right? I'm guesstimating based on these two numbers here. Let's call it 90 bytes, just to throw out a round number. The largest size being expressed here, again, let's be generous, we'll call it 300 bytes. So that means there's roughly about 200 bytes of data that got transferred when this session went by. We said the database is 1 gig in size. Let's do the math. 1 gig does not fit in 200 or 300 bytes, not even close, right? You might be able to argue, well, 1 gig database, but if we zip it, it's only 500 megs. Great. 500 megs doesn't fit 300 bytes. So if my boss came to me and said, did they get the database? I can look them square in the eye and say, absolutely not. But I can't promise what will happen next hour if we don't get them off that system right now, right? So by looking at the session sizes, you can figure out stuff like that. The other one to look for is, do you have a lot of small session sizes that are close to similar in size? If so, that's somebody scanning your network, right? They're they're either trying to log in under multiple accounts using the same password, and the size of the name field is, the login name field is a little bit different each time. So you're going to see a slightly larger amount of data going off a lot with a bunch of little peaks all in the same size. That's somebody trolling your network, or they're port scanning. They might be port scanning your network, in which case you're getting that same type of feedback. So if I see a bunch of little stuff going off that's just a little bit bigger than the heartbeat, that's somebody poking a probing around. Once I start seeing large data transfers, though, oh yeah, they're starting to grab files. They've found what they wanted. We're in bad shape here. All by just analyzing the amount of data that's going by. How would you search for session size in a tool like Splunk? Well, it depends on what data is getting stored to Splunk. So if I had, let's say, Zeke logs, right? Two of the fields in the con.log file that gets created by Zeke, and I'll talk more about, if you're not familiar with Zeke, don't sweat this conversation just yet. I'm just trying to answer the question. Um, we'll get into Zeke a little bit later when we talk about tools. But one of the things that Zeke records is how many bytes of data was sent from the client to the server and how many bytes of data was sent from the server to the client. So one of the things I would want to do is I would first want to go in and look for consistency patterns, right? I want to look for connection pairs, whether it be IP to IP or IP to fully qualified domain name, and I might not be able to get the latter out of Splunk to see, am I seeing a lot of data sizes that are the same? If you look at this chart, we had over 100,000 connections where it was 90 bytes of data. If I'm finding patterns like that, that's going to tell me that, yeah, I may have a command and control channel that's running here. And then I can look for variations off of that to see, does it look like the C2 channel has actually been activated? Now, once we identify beacons and long connections and we run them down, hopefully a majority of the time we can identify a business need that's associated with that. We don't want to hunt that every time, right? I don't want to like do a hunt this week and say, oh, that's Microsoft traffic and that's this other traffic that's okay. And then next week do the same thing. And next week, the week after that, do the same thing. So what we want to do is we want to create a self-learning, self-improving process. And one of the best ways to do that is with safe listing. So with safe listing, I go in and say, oh, hey, when a Windows system talks to anything that resolves to wns.microsoft.com, that's a Windows notification server. That's a understood business need function. I don't want to have those show up in my hunts anymore. So what my safe listing does is it basically identifies data patterns that I've seen before and removes them before I start my hunt. So now the only thing I'm hunting is new stuff. It's stuff that's changed. This is what I was talking about where, hey, your first hunt might take 3 days, but spend some time doing safe listing. And now your next hunt may only take a day. The next hunt after that might only take 4 hours. Your next hunt after that might only take an hour. Your next hunt after that might literally be 10 minutes, and that's it. So when you started with this threat hunt being a 3-day process, you're now down to it being a 10-minute process just by adding in safe lists as you go along. So how to identify business need? One of the things we want to look at is, who are they talking to? Can I recognize a business need that's associated with that? So again, it's a Windows system talking to Microsoft.com or Windows.com. Okay, those are known entities. So if I see that in my DNS records, they did a fully qualified domain name, I'll pick on the same one again, for some host that's under wns.microsoft.com. And so they did a fully qualified domain name search for that. And it has a digital certificate associated with that, and the digital certificate is valid. All right, they're definitely talking to that box. Windows notification services, yeah, we like to have that enabled because we have some applications that use it. This is legitimate. I can safe list this out and never have to worry about it again. Oh, these are the specific ntp.org time servers we use. We're going to safe list those entries so that they don't show up anymore. When you're running this stuff down, when you see odd ones you're not sure of, don't forget about your purchasing department, right? Like, let's say you see a beacon going out to Acme Corp, and you say, why are we talking to Acme Corp on a regular basis? Well, if you go to purchasing, more than likely some department purchased services from Acme Corp, And now you may be able to go back to that department and say, hey, so what's this software doing? Oh, it's leaking all sorts of private data. Well, okay, maybe we need to do something about that now. But hey, that's not a threat hunting problem, right? So we don't need to worry about that. We can pass it off to somebody else. But that may help you run these down by going back to purchasing. That's one I see. We're geeks. We tend to get technical. We use online resources. And when our online resources don't really pan out for us, we get stuck. Don't forget about your purchasing department. They can solve an awful lot of these for you. So that destination IP, who is it going to? What was the user trying to query? This is why DNS resolution is so bloody important for this type of thing. Because if I see you're connecting to an IP address out on the internet on a regular basis, how I feel about that is going to be drastically different if what you're talking to is patch.windows.com versus, evilc2.russia.ru, right? I mean, those two I'm going to have a drastically different emotional response to when I see that. So DNS records, critical. Now, a lot of sites log their DNS entries. The challenge with that is most DNS servers will log the queries, but not the answers. So, in other words, you'll see someone tried to get to patch.microsoft.com, but you don't know what IPs came back as part of that. So, you don't really know who did that. If you can get those answers as well, now you can map the two together and life becomes so much easier at that point. Well, but Chris, my DNS server doesn't log that. It only logs queries. How do I change it to get answer information as well, not just the query information? You don't have to, because my favorite tool, Zeke, will give that up for you as well. And again, I'll talk about that more when we get into talking about Zeke. Some helpful links for doing research. So as you see somebody's connecting to a fully qualified domain name or specific IP address, and you want to figure out what is that target? What's the history of it? Here's some links that may help you go through and do that. One of my personal favorites is Virus Total. Virus Total is really helpful for going through and kind of running down. What I like about Virus Total is it'll not only tell me, um, this fully qualified domain name, has anybody identified malware associated with it or anything like that? It doesn't just give me that type of info. It also gives me a history of what went on with that IP address. So if I see that it kind of looks like it might be a Microsoft name, but it's only been associated with that for a month, and before that, it's been associated with a ton of other domains, I'm going to be really suspicious about that. But if I see that that IP address is constantly been associated with some Microsoft fully qualified domain name for the last 2 years, yeah, that's probably an IP Microsoft managed IP address. I'm going to be a little bit less concerned. Doesn't mean I'm going to immediately dismiss it. I might want more than that, but it'll at least give me an idea of what's going on. So C2 detection techniques. Let's kind of talk through this a little bit. So we want to identify connection persistency. What's some of the tools that we can use to go through and do that? What are some of the techniques we can use to go through and do that? Um, some of this may be as simple as just looking for things like remote access ports or port connections going out to the internet that you don't expect to see, that aren't things that you may want to necessarily let out. Unfortunately, a lot of environments filter what comes in, but their outbound policy tends to be anywhere going anywhere. Just go ahead and let them do that. So we have a pretty liberal outbound policy. This is what allows C2 channels to be able to call out no problem. You want to, anything that has anything to do with remote access, you want to run that down. You want to make sure that this is a known entity for this internal host. Unknown apps on standard ports. So what I mean by that is, let's say I see traffic going to TCP 443, which is the well-known port for HTTPS. So that's encrypted web traffic. But there's no SSL client hello. There's no SSL server hello. There's no digital certificate flowing from the server down to the client. In other words, there's no legitimate TLS handshake that takes place. Well, that's tunneling, right? Someone is using a port that we know data gets encrypted on, so we probably don't bother looking at it that closely. and they're just obfuscating the data and blasting it out that port, feeling like if you did actually look at the data, you'd say, well, I can't read it, but hey, that's normal because, HTTPS is encrypted data, but there's no TLS handshake like there should be for that. So we want to look out for stuff like that. I have seen that take place on quite a few occasions. Now, I want to be clear here. This is not about running an application on a non-standard port. So, for example, I know a lot of folks like to say, okay, instead of having SSH listen on port 22, I'm going to have it listen on port 2222 instead. Is that something we should be flagging? No. Why would they do that? Well, I do that. And I do that because it helps to reduce noise. It doesn't mean you don't have to patch. It doesn't mean you can start using poor passwords. It's nothing like that. People do this simply because every script kiddie and their brother and sister are out there hitting port 22 on any system they can find, trying common password combinations. Now, if you've locked the box down, you don't have to worry about it. But that means you're going to get a huge number of SSH logs on a daily basis to go through and review to be able to say, nope, I have a good password policy here. We use digital certificates to authenticate over SSH. None of these passwords will ever work. I don't need to worry about this. Well, now you've got a lot of crud in your log that you don't care about. But throw it on port 2222, script kiddies aren't going to find it anymore. Now, anything that does generate an SSH log entry, it's now worth looking at and paying attention to. So folks will do this to kind of clear out noise. So that's not what I'm saying we need to worry about. What I'm saying we need to worry about is for our well-known ports where we expect to see a specific application using it. If it's not using it, if there's something else going on, that's when we need to get concerned. Now, Zeke can help us out here too. Zeke understands about 55 different applications. So when it sees a connection going to TCP 443, unlike most firewalls, which will label that as HTTPS simply because it's going to port 443, Zeke says, I'm going to decode the application layer. So if it's an SSH session, it will know it's an SSH session and label it as an SSH session. It's not going to get fooled by that. So this is one of the kind of cool features with Zeke. So for example, here it's seeing a connection going to port 80. It's labeling it as HTTP, but here it's seeing a connection going to port 80 and it's saying, I don't know what that application is. Well, that's because it didn't see a standard HTTP handshake. It didn't see a host parameter. It didn't see the HTTP version being identified. It didn't see a URI for any data that's being requested. It didn't match that pattern we expect to see on the HTTP port. So this is a great way to go through and just make sure, do a quick sanity check to make sure that what's on that well-known port is actually something that you expect to say. Let's see. Reach Chris Young is asking, is Zeke a competitor to Wireshark? So, dude, I don't look at it that way. I look at it as every tool has its strengths and weaknesses. So, for example, I have a million connections that went out to the internet yesterday. I want to use Zeke. To try and go through that with Wireshark is going to be tedious. And I'm probably not going to find any of the interesting stuff just because there's so much data to try and sort through. So, in that aspect, Zeke would be a better choice. But let's say I have found an interesting pattern between two different systems, right? I find something that I think might be a command and control server. I'd love to get a PCAP for that and run it through Wireshark because Wireshark's going to give me a lot more granular detail about what's going on. And because I've already identified that connection pair as being suspect, I don't have a lot of cruft to try and weed through. So I don't look at them as competitors. I see them as being different use cases. Lots of data to parse to figure out where the interesting stuff is. Zeke. Small amount of data between specific connection pairs, and you want to figure out every little tidbit about what's interesting. That's Wireshark. Or T-Shark is another good choice for that as well. I tend to lean a little bit more towards T-Shark versus Wireshark, but I'll talk about that when we get into the tools section. So that information within Zeke, we pass that through an AC Hunter as well. So, you'll see things like this where, hey, it's a TCP 443 session. We're labeling it as SSL. It could be SSL, could be TLS. That's just the way the Zeke reports it. But that lets you know yeah, that is actually the application taking place. We're not labeling it that just because it's a well-known port. Unexpected protocol use. So one of the things attackers are really good at is bending, not breaking the rules, right? It's kind of like the dojo scene in the original Matrix movie, right? Where Neo's being taught, hey, it's the Matrix. Some of these rules can be bent. Some can be broken. Your job is to figure out which is which type of thing. And attackers are really good at doing the same thing with some of our protocols. So one of the things we want to look for is abnormal protocol behavior. Now, that this sounds kind of all consuming, right? Like, well, what do you mean abnormal protocol behavior? Luckily, there's a couple of different styles of bending the rules that we can go in and we can take a look for. Yeah, I love that. You think that's air you're breathing now. That was like one of the best parts of that scene. So let's talk about how DNS can be used to create a command and control channel and how that differs from what normal DNS queries might look like. So here I've got a compromised system, right? And so I'm this attacker. I've got the little red thing sticking out of my head. I've gotten this person to click something they shouldn't have. I got malware dropped on this box. What I don't want to do is have this box start generating new traffic out to the internet because you might detect that. So what I do instead is I go out and I register a domain. In this example, I registered evil.com and I associate my command and control server with that domain. Specifically, my command and control server, I identify that as being the authoritative name server for evil.com. So anybody who wants to look up anything within my domain is going to end up at my command and control server. Is going to end up at my command and control server because that's listed as being the authoritative server. So now what I do is on my compromised system, I simply do a query within that domain, and I let your internal resolver forward that connection out for me. So the resolver will go out, it'll hit the root name servers, say, oh, that's a .com, go talk to those servers. It talks to the .com servers, and they say, oh, hey, go talk to this box. It is authoritative for that domain. So now my resolver is going out to the internet for me. So what I see here on the firewall is my resolver generating DNS traffic. Well, it does that anyway. So I may not even notice anything's off here. This may look like a weird query. We'll talk more about that in just a little bit. But now my queries are going out to basically say, hey, do you have anything for me to do? And my answers that come back are the answer to that question. No, go back to sleep. Yes, run the task list command. That's going to be encoded in the answers that come back over DNS. And the queries and the answers are going to be fully DNS compliant to make sure this resolver has no problem forwarding that information back and forth. It's a real stealthy way to do a command and control channel. This is actually a pretty popular way to go about creating a command and control channel. Because again, you're not seeing any new traffic coming off of this system. Okay, how do we detect that? Right? They're bending the rules here a little bit. How do we detect that? Well, if we define some common practices, or if we define some common ways that DNS normally works and looks for variations off of that, we may be able to detect this. So, for example, let's talk about this. How many fully qualified domain names does it make sense for a domain to expose to the internet? Right? Like you got a web server, a mail server, a couple of name servers, maybe DKIM entry, and we're still counting fingers on one hand, right? Most environments are going to have less than 10. Now, there are domains out there that you will always recognize their name that are larger than that. I mentioned Akamai. I didn't really have to explain what Akamai does. Everybody recognizes that. Microsoft, I didn't have to explain what they do. Pretty much everybody knows who they are. So these very large internet-based properties, you might see a couple hundred. If you're a class A global company, you might see 1,000 queries that are associated with one of these popular domains. But for everybody else, 10 or less. Well, this is kind of cool because now if I start doing things like looking at how many unique queries are being sent to a specific domain, that may give me a heads up as to whether that domain is being used as part of a covert communication channel. These columns here, this is the number of unique queries that took place. This is the number of actual queries. The number of actual queries, we don't care. That's just how busy that site is. We don't care about that number at all. What we care about is this number, because this is identifying the number of resources this domain is exposing to the internet. And in this case here, we have 62,468 for a domain we've never heard of. Oh, that makes absolutely no sense at all, right? That I have 62,000 servers on the internet. You've never heard of me? Yeah, I don't think so. This, it would be highly suspicious to me of being a potential command and control channel. This is something I'm going to have to dig into a little bit deeper. The other thing I can look for is utilization. So, for example, let's take a legit domain, akadns.net, right? In this case here, there were 13,000 unique queries. We don't care about that number. The number we care about is this one. 125 unique resource records were queried. Okay, this is Akamai, biggest content delivery network in the world. The fact that we looked up 125 resource records in their domain over the course of a day does not surprise me in the least. Like we said, these could be anywhere from like 200 to 600, and with that range in mind, this actual number is actually kind of light. But one of the things we can look at is utilization of those resource records. So, for example, what this information over on the right is telling me is that 3 of my internal systems did all of the queries within akadns.net. Well, if I've got 3 internal resolvers, I'd expect to see that. That's no big deal. What we really care about is this here, the direct connections. What this is telling me is that 13 of my internal systems connected at least once, usually multiple times, to one or more of these 125 resource records. This is what we expect to see, right? I go out, I want to go to a site on my web browser. I type in a name, DNS resolves it to an IP address. I connect to that IP address. This is how we expect DNS to work. Well, let's go back and look at this suspect domain. We looked up 62,468 unique resource records. The only system that ever talked to a resource in that domain was one of the DNS servers. That was it. Well, that doesn't make sense, right? So the DNS server looked up 62,000 different resource records, but none of our users needed to access any of those resources. Oh, that makes no sense at all. That's another pretty good indication we probably got a command and control channel here. So again, they can tunnel this stuff through DNS. But if we set some guidelines around, hey, this is how we expect DNS to work, and if we see variations off of that, we're going to pay attention to it. This is what's referred to as behavior analytics. What I love, love, love about this is that, let me go back here for a second. This was a text record query. And what I see a lot of tools saying is, oh, well, we'll look for an excessive number of text record queries within a domain. What does that mean? Right? Because that's not exactly a clean number. That might be a lot for Akamai. That might not be many at all for another domain. And it also implies the only way an attacker create a C2 channel is by using text records. I've seen CNAMEs used. I've seen MX records used. I've seen DKIM used. DKIM was my personal favorite, quite honestly, because DKIM was a protocol we created to make DNS more secure, and attackers figured out how to leverage that to make DNS more evil. I just the opposition of that just kind of, I've got a weird sense of humor, so that one just kind of triggered my sense of humor a little bit here. But, again, pattern matching on it being text records, yeah, not so much. But looking at it from a behavioral analytics standpoint, it doesn't matter what type of record is being queried. It all comes back to, this. How many unique resource records are you going after? Does that make sense for that particular domain? All right. You can also look for things like this. This command, so what I'm looking at here is a Zeke log, right? Zeke has a main log called con.log where it records everything. And then it takes the different applications and breaks them out into their own logs as well. So all HTTP traffic goes into http.log. So what this command is saying is list out all the contents within http.log. Now, rather than just having all that data spew by on the screen, I'm using this tool, Zeke, to say, I don't want to see all the data For each record, I just want to see the source IP address, the destination IP address, and the user agent string that was associated with it. That's it. Any other data that you recorded as part of that connection, forget about it. Don't print it out anymore. Then I'm saying grep this IP address. So what I'm doing is I'm saying I only want to see these records that are associated with this particular internal IP address. So now I'm saying this IP, every IP address it talked to out on the internet, and the user agent string that was associated with each of those. Then I'm saying sort that data. So anytime the source and destination IP address and the user agent string matches, that's going to show up in my output one line after another. And then I'm saying unique C, collapse it down to a single line. So if I talk to a IP address out on the internet 10 times using the same user agent string, I don't care about that. Collapse it down to one. If I talk to it 50 times, I don't care. Collapse it down to one. If it was already just once, that's fine. Just leave it at once. So I'm making sure every connection pair, I'm only seeing one entry for it. And then what I'm doing is I'm cutting out the user agent string part of it. And then I'm sorting and counting how often that was seen. So here's what this output is telling me. This internal IP address, 10.2.15, when it talked to 15 different IP addresses out on the internet, it identified itself as a Windows 10 system. When it talked to 12 other IP addresses on the internet, it used this user agent string, but also identified itself as a Windows 10 system. But when it talked to one IP address out on the internet, it identified itself as being Windows XP running Internet Explorer version 7 and running Java version 1.5. Whoa, what could possibly go wrong with that old version of Java, right? Oh, well, wait a minute. So for 27 different IP addresses that it talked to, it's claimed to be Windows 10. But for one IP address it talked to, it claimed to be Windows XP. That doesn't sound right. Now, this could be someone's running a VM that has Windows XP on it, right? And they're just connecting this one system out on the internet. That's possible. But I think we could agree that's an edge case, right? And if it's an edge case, you're probably going to know about it. In other words, the only reason people would be running Windows XP in a VM is because you've got some weird application you bought that they haven't bothered to update the platform they support. So you're kind of stuck with it and you have to use Windows XP. But even then, you're probably going to be talking to another internal system, not some host out on the internet. So the fact that it changes how it identifies itself, oh, that's weird. It's not breaking any communication rules, right? This isn't breaking the RFCs, but oh, you're definitely bending the protocol usage here, right? This is something worth paying attention to. And you can do similar on the SSL TLS side. So I can go in and I can look at how does that system normally negotiate a TLS session? Does that change for only one system it's talking to out on the internet? And J3 is a way we can go through and do that. J3 is in the process of being replaced with J4. There's things I like about it better. There's things I hate about it compared to J3. That's a good side conversation to have because you got to kind of get into the crypto side to really explain what's going on. But basically, all this does is it creates a hash that makes a unique identifier for the way that I'm going through and I'm negotiating those TLS sessions. So if I see I negotiate TLS a certain way, 27 times, 50 times, whatever, but for one IP address, it's different. Oh, I may want to go in and pay attention to that one. Now, we talked about, as part of this, you may want to investigate the internal system. How much information you have really depends upon how much data collection you do. And this varies a lot from organization to organization. So I'm not going to go too far down this rabbit hole. But, if I have something like Carbon Black, that could be super helpful because I may be able to go in and say, hey, I'm seeing a persistent connection from one of my internal systems to this host out on the internet. If I can jump into Carbon Black and figure out what application is making those connections, that may help me run down, is this something I need to be concerned about or not? But again, that only works if I have Carbon Black. That's why we created Beaker, because it's open source. Anybody can use it, and it's going to give you resolution into stuff like that. Leverage internal logging. Yeah. So now, once you find a persistent connection, once you find something persistent, if I have some sort of internal logging taking place, now would be the time to go in and take a look at that. because that may give me some additional insight. So the internal logging may not help me find the bad stuff when it's occurring, but once I know the bad stuff it's there, it might be able to provide additional context around that. And one of the best tools for doing that is just Sysmon. And again, this is a free Microsoft tool. So I can go in and I can record all sorts of crazy stuff with this. Like I said, registry key changes, permission changes. There's a ton of stuff you can log with Sysmon. But from a threat hunter perspective, what I find most useful is type threes. Type threes are applications talking on the network. So this could be I'm holding open a listening socket and people can talk to me, or this application is reaching out across the network to go talk to a server someplace. So it'll record both of those instances. And what this allows me to do, as we talked about before, is it allows me to map, hey, my IP is talking to an external IP. I saw that traffic on the network. Let me go figure out what application was causing that connection to take place. And I may see something like this where it just says Notepad. Oh, okay, cool. It's just Notepad. We know we're okay. Oh no, wait. Notepad doesn't talk on the network. And oh, by the way, that's a DigitalOcean IP address, not a Microsoft IP address. So Notepad would definitely never be talking to DigitalOcean. Something is horribly wrong here. This is not the Notepad we think it is. And again, I would never write a signature for my logs to go look for somebody running Notepad. I'd get way too many false positives. It works for PowerShell. It isn't going to work for Notepad. But here we have context. And our context is Notepad running on this system is connecting to someone out on the internet on an extremely persistent basis. That makes it worth investigating much further because it's definitely not the Notepad that we think it is. But I have no system logs. All right. If you have no system logs, it might be a good time to start thinking about how do I get some additional resolution on my endpoints. So what's next? At this point, we say we think it's safe. If so, add it to a safe list entry, or maybe we need to go into incident response mode. All right. And with that said, it is the top of the hour. So this one's also a 10-minute break. I'm letting you go a minute late. So we'll say 11 minutes after the top of the hour, we'll go through and we'll pick up from here and keep going. So I will catch you in 10 minutes. Hey, so we still have a minute, but I wanted to kind of talk about one of the questions that was in Discord, which is, um, wow, what are the requirements for funneling this much data? We're going to talk about Zeke in a minute. But again, this is one of the many things I love about Zeke is that Zeke is far more efficient than going through and creating a PCAP file. With a PCAP, you get everything. You get the Ethernet header, you get the CRC and the Ethernet trailer, you get the IP ID, you get a lot of information that you may not normally use as part of your hunting process. Zeke kind of gets to the good stuff, right? It tells you how much data went up, how much data went down, what was the timestamp for this stuff, what was passed on the application layer. Um, so Zeke is very efficient. It's about a 20 to 1. By that, I mean that, for every day's worth of PCAP files you could store or process, you can do 20 days worth of Zeke logs. And they process faster than trying to go through and deal with PCAP. So that's one of the things that you can go through and do to kind of help optimize this. But with that said, we're back into class time now. So let's go in and we'll talk about network threat hunting tools. So cap infos, one of so this doesn't help you parse data, but it's a great sanity check tool, right? If someone passes me a PCAP and says, hey, I'm seeing some weird traffic in here. Can you take a look at it for me? Cap infos is the first tool I pull out because cap infos is going to tell me how much data do I have to work with? Because if this is a 5-minute capture versus a 24-hour capture, the techniques I can leverage are different. The things I can look for are different. We talked about long connections. If I have a 24-hour capture, I will look for long connections. If I have a 5-minute capture, I'm not going to bother looking for long connections because even if I find something that ran the full 5 minutes, that's not really that long. That's not worth getting worked up over at all. So this is a great tool to kind of do that initial sanity check. You'll notice I used the switches A, E, and U here. That's specifically to print out the total duration time as well as the start and stop time of the capture. If I don't use any switches, it'll still print that information out, but it prints out a ton of other information as well that, maybe I care about, maybe I don't. You can kind of play around with it and see what you think for yourself. TCP dump has been around forever, and this tool tends to get ignored because we have a bunch of, newer tools. We have tools with GUIs, but what I like about TCP dump is it's universal. This is available on Linux, it's available on Unix, it's available on Macs. It doesn't ship with Windows, but there's a tool called WinDump that basically supports all the same switches that TCP dump does and works the same way. So this is something that's always available to you. What I like about this tool is it's a great tool for creating packet captures because it's very low overhead, very minimal. It'll parse PCAP files packet by packet. It doesn't necessarily have to read the entire PCAP into memory before it does anything. So it's super efficient for dealing with large PCAP files. As far as like how to use it to capture files, Bill wrote us a nice little bash script that's showing up at the bottom here. So what this bash script does is it goes through and it creates a directory called opt pcap, and you can choose to make the directory any way you want if you want to throw it in your home directory or whatever. That's just one possible example. But then Bill uses the screen command to go through and create a screen called capture that will run this command in the background, and you can connect and disconnect from it anytime that you need to if you want to watch what's going on with it. It'll then go through and listen on the Ethernet 0 interface. And every 3,600 seconds, which is once per hour, it'll write out a file and then start a brand new capture file. And when it writes out the file, it puts in the host name, the year, month, day, hour, minute, second. So you get a brand new PCAP file once per hour, and it tells you where was this peak capture created, what was the host name of the system that created it, and what was the timestamp on when this got written out. So this gives you a nice little history to go through, and then he even runs it through bzip2 in order to compress it to take up a little bit less space. T-Shark is the command line version of Wireshark. So they use the same decoders, they use the same engine. It's just, if you're at the command line, T-Shark's the tool to use. If you're in a GUI, you may want to use Wireshark instead. One of the things I really love about T-Shark is its ability to go in and define specifically what you want to go in and look at. So for example, T-Shark will print out a summary, same as TCP dump does, although it prints the information slightly differently and there are different fields they choose. But where T-Shark really excels is I can tell it exactly what I want to see. So here I'm running T-Shark -R. I want to read in this PCAP file. And when I say -T fields, I can then go in and identify excuse me. I can then go in and identify which IP, TCP, whatever fields I want to have get printed out on the screen. So here I'm saying -E dns.query.name. So that's saying, hey, look at DNS packets, look at what's being queried. And that's specifically what I want to print out. Now, every time this checks a packet, if it doesn't have a DNS query field in it, it's going to print out a black line. So what I did is I created a capture filter that says only do this on UDP port 53. That's going to limit it to my DNS traffic only. Then I just pump that through head-10. Head-10 just simply says, rather than printing out all the lines, only print out the first 10. And that's a great technique when you're setting your command up and you want to see if it's working properly. Usually within 10 lines of output, you can figure out if it's doing what you want it to do or not. So, that's odd. So, yeah. So, excuse me. So this is a great tool for going it. Now, the display filters, there's literally 25,000 of them. I was just checking to see if I have T-Shark installed on the VM, and I don't. But if you do a T-Shark space -G, that'll print out all of the different display filter options that are available to you. You can also go up to the Wireshark website. They have a list of all the display filters there as well. So you have a couple of options to be able to go through and figure out what display filters are available to you. But here's another example. So again, T-Shark -R, read in a PCAP file, -T fields. This time I'm saying -E http.user_agent. So it's going to look for HTTP sessions and it's going to print out the user agent field that was associated with the connection. Using a capture filter to say TCP destination port 80. So again, anything that's not going to TCP port 80, I'm not going to bother checking. And then I'm saying sort that data. So now anytime the user agent string is the same, that'll show up one line after the next. And then I'm saying unique dash C. So unique says collapse it down to a single line. Dash C says count how many instances there was. So this is going to go through and count up how many times each user agent string was seen. Now here I said sort dash n. So that's doing a numerical sort. Sometimes what you might want to do is sort dash rn, which will sort the largest numbers first down to the smallest numbers. It depends on what data you want to look at, whether it makes sense to look at big numbers first, then lower, or vice versa. But you can do either or with that. And then I just ran it through head dash 10, although quite honestly didn't need it because we had less than 10 entries. Again, it's really nice to be able to go in and pull out specific fields with this thing. Now, the graphical complement to T-Shark is Wireshark. There was a question earlier about, hey, so is Zeke a competitor for Wireshark? And I said, not really. They do the same thing. They decode packets. But the reason to me they're not competitors is that they have different use cases. Zeke is great when I need to parse through large amounts of data looking for interesting patterns. Wireshark is not as good at that because you're just getting way too much detail and it's a pain to go through and kind of filter through it. But once I have a target, once Zeke has shown me, hey, these two IP addresses talking to each other, that's kind of interesting. Well, now I can go through and look at that connection pair within Wireshark, and I might be able to pull out more information than Zeke would be able to show. So I see them more as a complement to each other. But like I said, at the end of the day, Zeke's one of my favorite tools. This is, my life would be so much tougher without Zeke. Let me put it that way. What Zeke is good for is it goes through and it writes out a summary entry for every connection pair it sees. So unlike a PCAP where you're getting a copy of every single packet, you get a single line in Zeke that says, hey, this IP address talked to that IP using this source port talking to that target port. How much data went back and forth? Here's how the application layer decoded. And then there may be another log entry that records the application data that was seen as part of that connection as well. So it gives you a nice little summary of everything that's happening on your network. So here's an example. So I mentioned that every time it recognizes the application, it'll create a file for that application and create a log entry in there. So there's a log called ssl.log. Anything that looks like an SSL or a TLS session will get logged into con.log. That's the log that tracks everything. And then additional data will get written out to ssl.log. And what'll show up in the ssl.log file is the application layer data. So here I'm saying cat that log file, pump it through zcut, and I want to only print out of all the fields of information that's available that are associated with TLS sessions. I only want to see the source IP address, the destination IP address, the destination port, and the validation status of the digital certificate. One of the things you can do with Zeke is you can have Zeke check the certificate, the digital certificate of every session that goes by. This is cool because if I asked you, how often are people using self-signed certs? How often are people trying to talk to a system that has a revoked certificate? You may not have any visibility on that. Well, Zeke can give you that visibility very easily. So here I said, only print out those three lines. And I want you to, grep says, only show me the lines that have self-signed in it. In other words, I want to look to see who's talking to servers that have self-signed digital certificates. Sort it, unique it, so I'm only getting one entry per IP connection pair. And you can see what I get here. So here I have a legal IP talking to a private IP address. It's talking to port 9943, and there's a self-signed digital certificate on that. Now, notice that's not on TCP 443. That's normally where we see TLS traffic taking place. But remember what I said, Zeke, anytime it sees a connection, will decode the application layer to figure out what application is using this port. So even though it was a non-standard port, 9943, Zeke knew this connection is using TLS. There's an SSL client, hello. There's an SSL server, hello. There's a digital certificate being exchanged. And as part of that, it checked the validation on that digital certificate and saw, oh, this is a self-signed cert. So now I know that's running on this box, right? This box is using a self-signed certificate. Here's all the different IP addresses that are talking to it. Dash D for human readable format. So Zeke by default prints things out in epoch time. So this is the number of seconds that have taken place since, what is it, January 1st, 1970, or some weird date like that. Somewhere in the January of 1970 timeframe. I always forget is at the beginning or the end of the month. But, honestly, it really doesn't matter. This can be kind of hard to human parse, right? When I look at that, quick, what was the date timestamp? Yeah, I don't know. I'd need to do some math. You can have it print out by using the dash D switch, the actual timestamp. The problem you'll run into is this. Notice that for my first 3 lines, well, actually more than 3 lines, it looks like these all happened at exactly the same time. Well, we get more resolution out of the epoch time. So you can see they didn't actually happen all at the same time. There was some milliseconds between them. We're just not getting that level of resolution down here. So again, which one to use kind of depends on what you need at the time. I just wanted to show you that's a potential option. Now, I use Zcut in these examples just because that's what's been there for a while. But there's another tool called Zcutter that was created by the illustrious Bill Stearns that quite honestly is a lot better than Zcut. Zcut has some limitations to it, like you can only parse one file at a time. Well, Zcutter will do multiple files. The other limitation with Zcut is that it will only parse Zeek logs that were saved in CSV format. Zeek also supports JSON format in order to save the log files, and some folks prefer that because it tends to input quicker when you're pushing that data over to some other application. Well, yeah, you can do that, and it improves that performance. But now you lose the ability to kind of parse the logs with Zcut if you want to get in and try and do something manual. Zcutter will work with JSON, no problem. In fact, one of the things he did, which because hey, Bill is Bill, you can have one log file in CSV format, another log file in JSON format, and it will parse them both at the same time and have absolutely no problem. Another cool build tool is Passer. So we talked about internal, seeing what's going on in your internal environment depends on how much data you're collecting. What if you're not collecting any internal data? What if you're not doing any logging? What if you're kind of blind? Well, one of the things you could run on your Zeek sensor is this tool here, Passer. What Passer does is Passer just sits there and kind of monitors the traffic going by to see what it can learn about the environment. So, for example, here it's saying port 43 is open on this system. How does it know that? Well, it saw somebody connecting to that port. It saw that port go through and respond. It also can give me some additional information about what that operating system might be. So if you have no data collection taking place on the internal environment, it might make sense to run Passer just so that if you run into a situation where you say, hey, so I've got this internal IP address 172.16.199.23 and I know nothing about it. Well, if you go into the Passer data, you'd be able to say, oh, hey, it's got PC Anywhere running on it, and all this other stuff is taking place. And oh, hey, look, it looks like that it was running Nmap and it was running a port scan. You can get some this is it's not necessarily as granular as collecting, ID3 logs with Sysmon, but it's better than nothing. And oh, by the way, you can run it on the same box that you're going to run Zeke on. Smudge is another tool that was created out of the team. Bill had a hand in this one as well. So there used to be a tool way back in the old days called P0F that was a passive fingerprinting tool. So this was a tool that would identify the identify an operating system, not based on probing it like Nmap does, but by simply looking at the traffic that's leaving that system. What's nice about passive fingerprinting is that you can't tell if I'm doing it or not. If I run Nmap against you, yeah, you might detect that. But if all I do is sniff your traffic and use that to figure out what operating system you're running, you have no way of knowing I did that. P0F was a great tool, but it stopped being supported. We haven't had anything like it since. This is where Smudge comes in. So Smudge will go through and create a signature and identify what operating systems are communicating. Yeah, Bill saying all the credit for that goes to David. Yes, David did do a lot of the work, but Bill, you did help. So deal with it. You're going to get some loving for it. Bill doesn't like taking credit for anything. Another fun tool is ngrep. So we looked at grep briefly. Grep is a tool that allows you to search a text file for a specific pattern. And when it finds that pattern, it'll print out that whole line. So in the context of the script that we were working with a little bit earlier, I was using grep to look for an IP address. And when it matched on that IP, it printed all the information on the same line that was associated with that IP address. Well, ngrep kind of does the same thing, but with packets. So with ngrep, I can go in and I can say, look for this particular pattern within the payload of the packets and print out any packets that have this pattern in the payload. Kind of a pretty cool function. So here I'm saying ngrep-q. So normally what ngrep will do is anytime it checks a packet and doesn't find the pattern, it'll print out a pound symbol. The problem with that, of course, is that it'll print out a ton of pound symbols. Any useful data immediately scrolls off the top of the screen. I don't know why they do it that way. I could see having that as an option if you need to do debugging, but leaving it on by default was kind of silly. So you need to use -q to shut it off. Also notice ngrep, the authors thought they were smarter than the rest of the world. We're not going to use -lowercase r like everybody else does. We're going to use -uppercase I for input in order to be able to go in and read the file. But once I read the file, check payloads for this character string, and it is case sensitive. When I tell it to run, it says, okay, I'm going to input that PCAP file you told me to. Here's what I'm looking for. And oh, hey, here's a TCP packet coming from this source IP, this source port, going to that destination IP address, that destination port. The TCP ACK and push flags were set. And in the payload of this packet was this GET request. And notice it includes that string. Here, similar, it's flagging it because anytime you try to get a file that doesn't exist, we get a 404 error that gets returned, 404 not found, and it will identify what was the URL that it couldn't find. And notice there's our admin pattern there again. So you can actually search payloads for things. It's not as useful today because most things thankfully get encrypted. But back in the day, you could go in and you could do a search for login and pass and end up with an awful lot of clear text login credentials that have flown by on the wire. Rita is our command line based open source threat hunting tool. So anybody can use this. It's designed to work from the command line. This takes Zeke logs and looks for those patterns that we talked about earlier. It'll look for long connections. It'll look for things that look like they're beaconing. Rita is named after my partner, John Strand's mom, who was an amazing lady. She was really cool. There's a Darknet Diaries about how she did a physical pen test against a prison and was able to compromise their network. That's just awesome. It's definitely worth a listen to. I forget the exact one. Oh, Bill gave a link to it. Awesome. So yeah, if you haven't heard that story on Darknet Diaries, definitely worth giving a listen to. So Rita is named after her. But like I said, this is designed to, the hard place is where to start, right? I got all this data. How do I figure out what I need to actually look at? That's the problem Rita is specifically designed to solve, is to help you figure out what do you need to go after first. So here's an example. So I'm telling Rita, I want to show any IP-based beacons that are associated in this data set here, lab one. The most important data point here is this very first column. This is a How certain are we that this is a persistent connection? So one means we're 100% certain this connection persistency here. 0.838 means we are 83.8% certain that there's connection persistency here. Well, Chris, why did you just write 83.8%? Why did you do it this way? Because percent is a special character and would mess with a bunch of scripts that people would try and create. It would make it harder to go through and automatically parse this data, and we didn't want to do that. But notice for this first one, we were 100% certain. We're telling you it's this source IP talking to that destination IP. Here's the number of connections that took place over the period of time being analyzed. Here's the amount of data that was getting passed back and forth on average. Everything after that, quite honestly, is kind of useless to you as a threat hunter unless you run into a problem. Back in the early days of Rita, we were having people give us feedback so we could make this tool better. Or we used to get more feedback than we do today to help us make this tool feel better. I guess that's a better way to go through and say that. But some of the things that had come up would be things like, oh, hey, I found this and I felt like it should have scored higher. All these other numbers tell my developers what were the attributes associated with this connection that caused us to score it the way we did. So what this allows for is if you write in and say, hey, I found some C2 and you only gave it a score of 80, and I feel it should have had a higher score than that, you could go through and say, and we would go through and say, hey, send us the whole line. And now we could look at that and say, okay, why did we score it as an 80? Now, what is it about this connection that's unique that might allow us to tweak our scoring method to score it a little bit higher the next time? So, like I said, it's really just the first couple of columns you're interested in here. Rita can also look for things like um, beacons going from a single source out to multiple IP addresses. It can look for things like beacons going through a SOC server. It'll look for long connections. It'll look for C2 over DNS. It has a lot of flexibility to it. But we haven't replaced it, but we've basically created a graphical front end for it that for the longest time was just enterprise. Now there's a community edition of it too, so you can use it for free. But Rita is still doing its thing in the back end. So Rita always does the data processing. How it gets presented depends upon whether you're just using the raw Rita tool or whether you're using AC Hunter. Some of the things AC Hunter brings in is things like prioritization of the systems. So, for example, this left-hand side of the screen, here's my internal IP addresses sorted by threat score highest at the top. Well, if I want to go look for potentially compromised systems on my network, where do you think I should start? Probably the very first line, right? So we make it easy for you to kind of figure out what systems do you need to pay attention to first. Over on the right-hand side, it breaks down where did those threat points come from? So, for example, here I can say, oh, there was an IP-based beacon that was going off that had a 94% score to it. Okay, that's why. So now I should go look at that connection to see, if it's definitely a persistent connection. Is there a business need associated with it? If there is, I can just safe list this and be done. If not, I need to go down the rabbit hole a little bit deeper to figure out what's going on. The beacon screen, we've looked at little pieces of this as we've gone through. I'll show you this off to you more when we go through and do our hands-on walkthrough. But up on the right, this is always going to identify what data set are you currently looking at? What was the date time range that this is involved with? Yeah, and what's the name of the database itself? So this will also always kind of give you a handle on what is it you're looking at. Also, I kind of want to just draw your attention here for a second. Notice I mentioned we can tell you what the user was trying to get to. So what this is telling us is that someone looked up alpha.saint and dot, dot, dot. Well, if this was the actual interface, I could mouse over it and it would show me the whole thing. But this is telling me they're trying to go to alpha.stjameschurch.org. It's kind of a weird connection to be making to from a business, right? That's kind of a weird domain for somebody to be connecting to. So I may want to go in and do some additional investigation work on that. So again, these were blank the last time I showed you the screen. Here it's filled in. I just kind of wanted to explain that through for you. The 24-hour graph at the bottom, we've talked about this. You don't need more. help from me on that. That little graph, we talked about this, the time analysis. So this is identifying how often each delta time between connections was being seen. And we said something like this tells me it's being randomized. If I saw a single line here at one time interval, okay, that's a regular connection. I'm still going to investigate it, but I'm not as nervous about it because there are legitimate apps that'll use a fixed frequency beacon. Notice this over on the right. This allows me to change between view one, which is timing mode, and view two, which is session size mode. And my session size, we talked about, I'm going to have a big peak in there somewhere. This is going to be my compromise system calling home saying, hey, do you have anything for me to do? No, go back to sleep. Anything bigger than that, that's data transfer. So notice here, we're seeing maybe about 1,800 bytes being transferred. We get a little more data going back and forth. I'm still not going to completely freak out, but this is looking a little bit more to me like they're starting to probe around the network, right? It's about 800 bytes just for the heartbeat. We're seeing here, we'll round that, call it about 1,100 bytes. That kind of sounds like somebody starting to probe the network. And it looks like there's at least a couple of dozen of connections at about that size taking place. So this to me looks like, yeah, someone's starting to, use this command and control channel to poke at the rest of my network to figure out what they might also be able to get access to. How do I know this is a failed connection? I know this is a failed connection because my IP header is 20 bytes in size. My TCP header is 20 bytes in size. So that's 40 bytes. So if the only thing that went back and forth was one IP header and one TCP header and that's it, well, the connection failed. It wasn't able to complete the connection after that. Now, we have some investigation capability up here. I was just talking about, Alpha St. James Church down here, but you can see there's other data we can kind of pull in, like the protocol data. What was the recognized application that was there? The IP address or fully qualified domain name at the top. If I click on that, I get a little investigation menu that opens up. And I don't have an example of it here. But an investigation menu will open up for external websites like Shodan and Google and VirusTotal. And if I pick one of those options, I'll immediately open up a new tab, open up a connection to that website, and then use this IP or fully qualified domain name as a search parameter on that system to be able to go through and look at what data do they know about this. With the enterprise version, this is super helpful if you have internal logging taking place in your endpoints, or again, you're running something like Carbon Black, because you can go in and you can add a menu option for your EDR software so that you can quickly jump into that, continue with your investigation. We were looking at other examples where it was showing IP address. If it's potentially going through CDNs. We can also look at it from a fully qualified domain name perspective. So you may see a fully qualified domain name up there as well. Sometimes these things get truncated. So you can see like the dot, 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 dot. Well, here I moused over the IP address and it'll immediately open up and show me all the other IP addresses that were associated with it as well. Long connection screen, I already talked you through this one. We don't need to talk about it again. The one thing I didn't really get into is I talked about how Zeke doesn't log open connections. It logs the connection after it closes. And I mentioned that we wrote a module that will log the connections while they're in an open state. Those get recorded here within AC Hunter. So these are all listed as being closed, but if it was a live connection that was still open, it would list it as being open instead here, just so you can tell the difference between the two. Threat intel. So I'll be honest, I am not a big threat intel fan. I'm not a big threat intel fan because it doesn't fit the model we need to worry about today. Threat intel was great when our threat vector was little Bobby living in mommy and daddy's basement trying to own more systems online than his buddies who play the same online game. In other words, it was about mass propagation. It was about, who can own, 5,000, 10,000, whatever number of thousand systems. That's not our threat vector today. A threat vector today is nation state. It's crime organizations. They're going to target you specifically. They're going to do their homework. They're going to look at What security job postings and IT job postings have you made? And what security tools have you been looking for skill sets? So in other words, if you did a job posting and said, "Yeah, we want to hire someone with carbon black experience," guess what that tells the attacker about your environment? That you're probably running carbon black. That's why you're looking for that type of experience. So now they know, oh, you have an EDR solution, your EDR solution is carbon black. So we need to make sure that whatever malware we push down looks like it's digitally signed by a legitimate authority you would recognize. Okay, cool. So here's what we need to do with our malware to be able to get it past your EDR system. So you get the idea. They'll go through and they will size you up specifically. So to know that an IP address was hostile at some point over the last year doesn't really help you much because again, they're not mass propagating any. I did some research a couple months ago and I went in, I was looking at different threat intel feeds. And what I found was that the false positive rate, how often when it generated an alert, it ended up being something benign, right? Like maybe that IP address was evil 6 months ago, but now it's, Jill and John's pizza shop. And somebody was just trying to order a pizza for lunch. And your threat intel software jumped in and stopped that. Ooh, evil pizza, right? It's a false positive. How often do false positives get generated by modern threat intel lists? The best one I found would throw a false positive 1 out of every 3 detects. That was best case solution I could find, and that was a commercial list. When you get into like the open source stuff, it was as high as 9 out of every 10 are false positives that you don't need to worry about. So they don't really, it's not really that helpful, right? What we do with AC Hunter is we allow you to set a couple thresholds. One of in the community edition doesn't do this, but the enterprise version does. It allows you to go in and say, "Hey, don't tell me about a system unless you see the score change 10 points or more." Right? So I can go in and I can say, "Hey, if the beacon score goes up by 1 point, yeah, I don't care about that. That's just, systems change a little over time. That's no big deal." So I can go in and I can set a threshold like it's going to change by like 10 points or more. Configure AC Hunter to say, hey, if you do a threat intel detect, only score 5 points. Because think about it. Your threshold is 10, threat intel is set to 5. Well, that means if we match something on your threat intel list, we're not generating an alert. Well, wait, Chris, how do but what if I need to see it? What if it turns out to be malicious? Because what we do is when we match against your threat intel list, we also start watching how much data does your client send to this system that's on your threat intel list. Because think about, that example I gave, it was like, you know, Gene and John's pizza shop or, whatever it was, the example I gave. How much data is the client going to send to the server? Not much, right? It's going to be, they're going to send, um, let's take worst case, say it's HTTPS. So I'll send my client hello packet. I'll send my user agent string encrypted. I'll send any URIs for data I want to request. Might be a couple of gets and puts if I got to put in my credit card information. That's it. It's not much data. So what we do is we have and again, you can tweak this in the enterprise version. We set a threshold of 5 MB. If the client sends 5 MB or less, which is not much, to that server, that 5 points is the only thing that gets assigned. You do not get an alert because I can guarantee that's a false positive. But if it exceeds 5 MB worth of data, it's pushed up to the server. Now we'll start adding in some additional points. If it gets to 25 MB, which again is not much, but if that's certainly way beyond what you would see in a false positive, we've added in 100 points at that point there. Well, this is kind of cool because now instead of chasing your tail with false positives with your threat intel list, the tool will sort them out for you. So the only ones you really need to worry about are the ones that are actually, hey, that client's pushing a decent amount of data up to that server. I really should get in and check this one out. There's also a cyber deception module in there. This is a little bit complex to try and get into in a lab in this class, so we're not going to get into it. But what the cyber deception module allows you to do is I can go up and I can say, I want to create a token. And then I need to identify what kind of token I want to create. So that could be a user, it could be a file, there's a bunch of different options. And let's say I want to create a user token. The user token is going to end up being a bogus login name. So I can go in and I can say, I want to create a user token named John Doe, who is an administrator in the domain. And what we will do is we will spit out a PowerShell script that you can then go run in your domain controller that will create this user John Doe, that will create that user John Doe with a 32 character password. So that's not getting broken in anybody's lifetime here. And it will create that user within your domain, and then it'll turn on full logging for that user. So the concept is when an attacker breaches a system and they want to start moving laterally, there's a couple of techniques they might use. One of the most common is to try and log in using legitimate accounts. Well, if they try to log into an account, and start spewing a bunch of possible passwords at it, the lock will trigger, right? Usually we say, hey, 3 attempts, 5 attempts, in X amount of time, and we're going to lock you out. They don't want to trigger that. So what they do is they use Windows' wonderful ability to enumerate all the users on that domain without having to authenticate. Yeah, that's a real great idea. And they get a list of all the users on that domain, including this John Doe user. And now they go through and they will take some common passwords like, oh, I don't know, winter 2024, spring 2024, something like that, or 2024 winter, and start trying that password against each account one after another, going slow enough to make sure they're not triggering a lockout at any of those accounts. Well, now one login attempt to John Doe that is an account no one's using, this source IP address, oh, that's a user that's gone rogue or that system's compromised. Either way, I got to pay attention to it. Another fun one is create a file on your net login share. Back in my pen testing days, that was always like my first stop because you go to the net login share, you can access all the files on it without having to authenticate, and that has everybody's login scripts. So I can use those login scripts to figure out where all the juicy resources are within your environment and do it without having to, do something noisy like run nmap or something like that. Well, you create something that looks like a juicy login script. It's not assigned to anybody's profile, so no one's ever going to touch it. The only one who will is someone who copies all the login scripts down off of the net login share. So again, now you get an alert telling you, hey, this internal IP address, you got a rogue user, you got a compromised system, you got something you got to go in and pay attention to. There's also a deep dive module. This allows you to go in and investigate all the connections that are taking place between different systems. So, for example, I can put in a private address and this is always in perspective to the other side of the firewall. So, when I put in a private address, it'll show me all the legal addresses I'm talking to out on the internet. We color code them. So, anything orange is suspicious, anything white is not. You can click on these, and when you do, we'll expand out, we'll show you here's summary about the information that was being carried out between those two systems. I can also hit this little P for pivot to reverse what's being checked out. So now if I was to hit pivot here, now this 165 address would become the center of the circle, and I would see any private addresses on my internal network that system is talking to. This is super helpful once you identify you've been compromised. So, for example, imagine we go in and we figure out, oh, hey, this system's compromised. It's calling home once per minute. Well, we said, hey, we want to get a handle on scope before we really do anything. Is this the only system that's been compromised? Well, if I go into deep dive and I look at the IP address that system's beaconing out to, I can see are any of the other internal systems beaconing out to it. Typically, what an attacker will do is they'll get in, they'll breach a system. That's their primary conduit into your environment. Then they'll breach multiple other systems, and those become backups. Those call out to the same command and control server, but they do it at a much slower interval. So while the main one might be calling back out once per minute, I've seen the other ones do it anywhere from 6 to 12 hours. So there may only be one, one or two or four connections a day going out, and that's it. So what happens is, imagine you find the one that's calling home once per minute, once per hour, whatever it was I said. You find that one that's calling out once per minute, and you isolate it, take it offline. Well, their command and control server is set up to say, hey, if you don't hear from that system for a certain amount of time, promote one of the secondaries to be the primary channel in. So we've all heard those horror stories of sites that said, yeah, we found a compromised system and we isolated it and cleaned it up. And somehow the attackers got back in a couple hours later and we're not sure how. Oh, they didn't get back in a couple hours later. They were on your network the whole time. You just hadn't found them yet. So again, what's cool about this is, we're working with 24 hours worth of data. So even if it's only calling home every 12 hours, you're still going to see it. So I might jump in here and say, and put in that IP address of that C2 server and see 12 other systems. Well, now I know all those 12 systems are all part of scope at this point. I need to isolate all of them at the same time, not just this primary communication channel. Install process, pretty straightforward. You can, there's a couple of different options for deployment. There's a VM. I like the install script just because it gives you a lot more flexibility and you can do things like, we'll ask you, do you want to install ActiveFlow? Do you want to install Beaker? ActiveFlow is another one of our projects that we support. Um, if you do, if we will install Zeke for you. Zeke can be kind of a pain to install. It's not the simplest tool to get up and get going. But if you run our install script, and oh, by the way, this install script is available for both the community edition as well as the enterprise edition. So you could download the community edition install. And when you run it, have it do the install for Zeek for you. And we'll make all the little tweaks we do to Zeek to optimize it for speed, just, log those open connections. We take care of all of that for you. So I find it just a little bit easier to work with. What's the difference between community and enterprise? I'll let you read this if you care. The short answer is we wanted to put a tool out there that anybody can download for free. That if you're in a situation of, hey, I think we're compromised, but I'm not sure. How do we figure it out? Download the community edition. That's going to show you if any of your boxes are compromised or not. Now, if you're in a position of saying, hey, we want to monitor on a regular basis and run this data through our SOC to see if we're compromised, and we want a real-time detection of, hey, this new system has a new beacon and it's not going any place you've seen before. It may be worth paying attention to. That's the type of stuff you need to go to the Enterprise Edition for. Data Mesh. This is a really cool tool, and it tends to get overlooked. Data Mesh is basically it's a variation off of the old R-based tools. So it's a statistical analysis tool. So you can give it a range of numbers, and you can tell Data Mesh, I want to see the minimum, the maximum, the mean, the average. It'll do all that fun stuff for you. But the other thing Data Mesh can do, which is really cool, is you can use it to add numbers one line to the next. Let me show you an example of that. So here I'm saying catcon.log, Zeke cut. I want the source IP address, the destination IP address, and the duration. Sort -K3. So sort -K3 means sort on the third column, which is this one here. -RN, this is a numeric value sorted highest to lowest, and print out the first 5 lines. So all this is doing is just saying, hey, I want to see the longest duration connections that are taking place on my network. Sort them highest to lowest because I'm most worried about the longest duration connections. Now notice I got some dupes in here, right? The second and third line, that's the same source and destination IP address. This first line and this line here, again, same source and destination IP address. What if I want to add those up? Well, in that case, I extract the same data, but I run it through data mesh. I'll come back and explain these grep statements in just a second. What I'm saying with data mesh is when column 1 and column 2 are the same, when the source and destination IP addresses are the same, sum the values in column 3. Then sort -K3. Notice doing that with the same data, I'm seeing some longer times in here than I saw before. It'll actually go through and start adding stuff up. All right. Now, what's with this grep stuff? Data mesh will only work with numerical values. So if it sees something that's not a number, it will just exit at that point. This command here says remove any blank lines from the output, just to make sure we don't have any of those, because again, it wants a number. This says if the duration is a dash, which is how Zeke will log a failed connection. It's not a zero duration time. It tried to connect but couldn't finish. It'll log that as a dash. Well, that's not a numeric value. So we need to remove all those lines out of the data. So we're removing blank lines. We're removing any dashes for the duration. And then we're running it through a sort. Because see here, I had this pair and this pair had stuff in the middle. I can't have that. I got to have them all one line after the other. That's what this sort's doing. Then data mesh will go through and add that stuff up. Another fun tool, Beacon Simulator. One of the things you really want to do is test your ability to detect beacons taking place on your network. So Beacon Simulator, again, thank you, Bill. Bill wrote this tool too. Beacon Simulator allows you to go in and do things like say, hey, I want to create a beacon with this IP address that's going to target TCP port 80. It's going to go off every 30 seconds, but I want 10 seconds worth of jitter. It's going to be, it's port 80 TCP. And I want to jitter the payload. Now, we said we're not seeing any beacons out there yet where you can jitter the payload. But if you want to test if you're ready for that when attackers start doing it, Bill's already built that into this tool for you. You can also do this with some simple scripting, right? Here I've got a script that just says, hey, use curl to connect to a site. And I'm going to use the sleep function with shuff to pick a random number between 200 and 350 and sleep for that number of seconds before I run curl again. So curl is creating my, connection TCP 80, and sleep is giving me my jitter dwell time between connection attempts. And I can even run this as screen in the background. And you can do stuff like this for yourself. Some of my most useful threat hunting tools are tools I wrote myself. So like this FQ command. What the FQ command does, it allows me to specify this is the script up here. And all it's really doing is it's saying, hey, when I specify a fully qualified domain name or an IP address, I want you to search the DNS log file, the HTTP log file, and the SSL log file looking for that value. When you find it, print it out. So now let's say I did a hunt and I saw something weird going to this IP address. I just say FQ space that IP address. And now that tells me, oh, that was, fwadsafeprotect.com associated with this IP address. Here's a CNAME associated with it. There was no HTTP traffic associated with connections to that IP, but there was HTTPS. Here was the SNI information. Here was the name of the system that the digital certificate was issued to. And look, that matches the DNS data, so that's a good thing. And the digital certificate was okay. All by just running a simple little script. All right. It is top of the hour. It's like I ran about 3 minutes over. I apologize for that, but I want to make sure we stay on time. This is our longer break. So 20 minutes after the top of the hour, we'll pick up from here, start doing some walkthroughs and hands-on labs. So if you don't have your VM up and running, now is the time to do that. So I will be back in about 17 minutes. All right, we are back. So we're going to do a little bit of a walkthrough together. So this should be kind of fun. So there's two different formats that I use for these. One is a guided walkthrough. So with a guided walkthrough, I'm going to do things on the screen, and I'm hoping you're going to follow me along on your screen. So when I introduce you to a new tool or technique, I like to do a hands-on walkthrough first. It's better than just like dumping you into the fire and saying, here, figure it out. Ha ha. That's not fun. So we're going to go through some stuff together, and I'm going to show you how to navigate and where to find different things. And then once we go through and do that together, then I'll go through and say, okay, now we're going to do a lab. And the lab is, here's a problem. I want you to figure out how to solve it. Now, I've noticed some repeat offenders in the audience. I won't call out anybody specifically, but I've noticed some folks in here that have been here before. And hey, that is freaking awesome, especially since those are the folks that help out the most with people who are having trouble getting the VM going and stuff like that. So kudos to people. But for the folks that have been here before, you can use the lab, what the lab problem is, and try and jump on it and go from there. But if you're brand new at this, you might look at the lab problem and say, okay, I kind of understand what you're asking for. I'm not really sure of the path to follow to get there. Well, the next slide after the lab, which I won't cover, is the hint slide. So you can go to the hint slide, and I'm not going to give you the answer, but I'm going to try and help point you in the right direction. So you might be able to look at the hint slide and say, okay, I kind of figure out what he wants to get accomplished here. Let me kind of go at it from there. So, and just a reminder, if you're working on the command line, login name is threat, password is hunting. If you're on the shared instance out on the internet, you will not have access to this, so that doesn't apply to you. For the web login, threat at activecountermeasures.com, password is hunting2. And again, the instances out on the internet, you do have access to that. You just may not be able to delete databases and add databases and stuff like that. So for the folks that are on a VM, finding the lab files, let's start there. So when you log in, you're going to be here, right? You'll log in and it'll just, actually, you won't be here. You'll be here. So you'll see that prompt there. Okay, where am I? Well, you're in the home users directory for threat. If we type in the command pwd is in doctor, that will show you where you're currently located. If I type in ls, that'll show me everything in this directory. So that's kind of the equivalent of dir on like the Windows side. And it's the labs directory that I'm interested in. So I'm going to say cd space labs. And now if I type ls again, you won't have that file. Let me remove that. So what you should see is this: lab 1, lab 2, lab 3. That's where we're going to be going in and doing each of our labs. Okay. When you go to log in to the web interface, I've got a bunch of stuff up here. What do you use? If you're working with VirtualBox and you're logging into a VM that you're running locally, here's the URL you'll use, right? Because we're connecting to localhost. Oh, excuse me, I take that back. If you're within the VM itself, right? So if I am here and I say I want to log in as threat hunter, password is hunting, hit enter. Over on the left, once this finishes loading, I'm going to have a Chrome web browser. So if I use the Chrome web browser here and I want to connect to AC Hunter, it should connect automatically. I should have set that as the default page on these. Yeah, oh, Chrome, I don't care. Stop. Yeah, I got it. Go away. Cancel. No. There we go. So once you get rid of all the, I want to patch and load crap, you'll get this. Your connection is not private. Well, that's okay. We're on a local VM. No big deal. So you can come down here to advanced, click that, proceed to 127.0.0.1, which is unsafe. That's okay. And then here's a login. So threat at countermeasures.com. And then our password is hunting and then the number 2. Once I do that, should be able to log in. Now, the first time you log in, and this goes for everybody, not just if you're logging in locally on the VM, you'll get this window. It'll pop up and say, hey, you need to select a database to log in with. Use this one, DNSCat-JA3. Click the little radial button next to it, click confirm. You should see it load up. You'll see some data on the left-hand side. You're off and ready to the races. If you're on the shared instance, the data might look a little bit different. Don't worry about that. So that's if you're logging in off of the VM. Now, if I'm logging in using VirtualBox, let me find another tab for that. That is, where to go? This one. So I'm running VirtualBox on my local system. So I'm going to connect to localhost : port 10,443. Once I connect to that, I'll get my login prompt, log in from there. If it gives me my warning that it's not safe, tell it that's okay, advanced, it's safe to proceed, go ahead and connect. Type in my login name, password, select that, uh, DNS cat2-JE3 dataset. I'll end up here. So kind of similar to what we ran into before. The easiest one is probably VMware, because with VMware, I'll launch a new browser tab and I'll just connect to this IP address. Unless I found that it changed the IP address on me. And, we talked about the way to figure out what the IP address is on that system is I can go in and I can say IP address, pump that through grep, and I'm going to say INET. You want to do 192.168 if you're on a VMware instance. Since I'm on, and actually I want to change this one up a little bit. I'm going to say -FW. There we go. That's a shorter list. Because I'm actually using the 10 address when I'm working with VirtualBox. But this command here will list out all your interfaces. But again, if you're on VMware and you're trying to connect to this IP address and it's not working, IP space address space pipe it through space grep space 192.168.149, hit enter. It'll print out an IP address. That's the IP address you want to connect to in your web browser. And like I said, for everybody, start with DNS cat2. Cool. So let's kind of talk about what you should see. So the left-hand side of the screen, this is our, excuse me, this is our list of internal systems ranked by threat score. If there's a system I want to see that isn't listed here, I can go up and I can do a search here. So I could go in and search for a particular IP address, or I could search for a particular subnet. Let's see if there's a good example of that. Yeah. So if I wanted to say, hey, yeah, that's nice, but I want to see only the systems on 10.55.200, I could hit enter on that, and now it'll filter it down to just those systems. So I get some control over what I see, but the default is to show me highest score at the top. Over on the right, this shows me my breakdown of what's actually generating some threat points. So notice under threat intel, I've got a match, but only 92 bytes of data were moved. Yeah, okay, we don't care about that. That's not going to be a big deal. I have a beacon score that's 99.9%, and I have beacon web score that's 99.5%. Anytime I see a high scoring beacon and web score at the same time, I always jump into the web beacon first. Why? Because I usually get a little bit more data to be able to work with here. And a lot of times it's the same entry. We're showing it to you based on fully qualified domain name, but we're also parsing out the IPs in case you need that view for some reason. But this will allow me to go through and see what's there. And again, we kind of looked at this before a little bit. Here's my timeline over 24 hours. Here's how often each time interval was seen. Notice if I mouse over, this tells me 40 connections were taking place at 1800-second intervals. I got another one out here. There was one connection that was a little bit of a longer extended period of time. Here's my list. Now notice when I jump in, so there's two ways to load data, right? From the main screen, I can click over on the right. And as soon as I do that, the tool says, you're investigating this source IP address, 1055.100.111. So anything I go to is always going to be in reference to that source IP address. So for example, if I jump over to client signatures, it's only going to show me stuff that's associated with that IP address. Now, if I don't want to see just a single IP, if I want to see all the data of that particular data type from the main page, instead of clicking over on the right, I click one of my modules down on the bottom. So if I go to client signatures here, now I'm seeing everything, right? And it's probably more even noticeable here because you can see it's automatically filtering on 1055, 100, 111 each time. But if I jump straight into the web beacon module here, notice you see in different IP addresses. So if I want to hunt a single system, select the system here, pick a score over here, and then as I jump around in different modules, it's always going to be that one. If I want to look at that specific type and everything associated with that type, just go straight in from the module perspective. So I got a couple of ways I can go in and kind of parse this stuff through. I mentioned the views over here. So this is showing timing. This is going to go through and show me based on session size. So I had 11 connections that moved 828 bytes of data. I had 36 connections that moved 868 bytes of data. So that'll give me a good view of what's going on. Here's how many connections took place over that 24-hour period of time. And there's always some useful information up here. So what this is telling me is that this went to cdn.onenote.net. Here's all the IP addresses that were associated with that. This was a HTTPS connection, right? This says SSL. Zeke labels both SSL and TLS connections as SSL because that's the older of the two. I wish they would update that. No one's really using SSL anymore. I wish that said TLS, but they're doing what they're doing. What this is saying is there was traffic going to TCP 443, and I recognize that as being in a legitimate SSL/TLS session. There was a digital certificate that was issued to cdn.onenote.net. Notice it's been issued to Microsoft. Here's some address information about them. Now, this kind of confuses folks sometimes. Invalid certificate. No. Well, that means it's a valid certificate. So that means this certificate's okay. So anytime we see yes here, that's when we get worried. If it says no, we're in good shape. So now I know this is going to cdn.onenote.net was what the DNS query was for. And that has a valid digital certificate that's been issued to Microsoft. Well, that's OneNote. So if we know we use OneNote within our environment, this is a legitimate business app, I don't want to see this anymore. So what I can do is I can go to this little filter icon. So this will work for anybody using VMs. It's not going to work if you're on the shared instance because you can't create safe list entries. But if I click on that little filter icon, I get a safe list entry screen that pops up, and I can create a safe list entry for it. So I could choose to create, I can identify what should be the source for this. Is it just this IP address, the subnet? Is it for any internal system that tries to talk to this host out on the internet? I'm going to leave it on anybody because we're saying this is a legitimate business app. Anybody internally can talk to this business app, and that's okay. I can say, what do I want to have it resolve against? So let's say I know that there are other hosts besides cdn.onenote.net that we talk to as part of this. I can come down here and click wildcard match, and I can say, take the little slidey bar, move it to the right, and now this will say anything within onenote.net is okay. And then I can go in and write a comment that says, see, Brenton created this entry on, February 23rd. Per JIRA ticket 12345, however you want to go about creating comments for these. And you really should create comments because I can guarantee a year from now you'll look at this and say, what's that? Who created it? Why? Well, if you've got that information in the comments, you're all set. And then once I go in and identify that as a safe list entry, this is going to go through and this is going to update my data. And once it does, notice that entry disappears. And my next entry now is config.edge.skype.com, which also has a valid CNAME and also has a valid certificate associated with it. With the enterprise version, these are filtered out by default. We have a default safe list entry that we ship with the enterprise version that cleans out a lot of this stuff so you don't need to worry about it as part of your first hunt. And then you can go in and add anything that's just unique for your environment. The IP-based beacons, this is going to go through and this is going to show you anything going out to a single IP address. We get to see what domain is it going to. We don't see that on the other screen because those IPs might be part of different ASNs. They might be in different locations. So this only really works when we get into like an IP-based investigation. Well, actually, one of the, I could have shown you there too. So let's say I'm looking at this and I'm saying, oh, it's going to DigitalOcean. I don't really know why it would be going to DigitalOcean. Do I need to worry about this IP address? Well, I can click on that IP address, and when I do, this little menu appears. And I can say, oh, hey, VirusTotal, tell me what you know about that IP address. And now VirusTotal will come back and say, oh, well, We've had 90 different sites look at this IP address, and none of them have associated any malware with it. This IP address is currently associated with this fully qualified domain name. This is the last one we saw associated with that. And here's the history over the last couple of years. Like I said, this is super useful for something that's like well known, like a Microsoft system. If it should have always been some form of Microsoft system. If it's not, that might be a problem. So I can go in and I can look for stuff like that. I can go under details. That'll give me some information about what's associated with it. I'll leave it to you to kind of poke around and play if you want to. But by clicking that menu, I have this investigation menu that pops up. I could also I could go into the deep dive module, and it will automatically load up this IP, and this will show me which internal systems it's talking to. So I'll get if I click the IP address, it'll give me a little summary on the right. It'll give me a little communication signal so I can see how often it's been talking. And like I said, if I ever want to pivot, I want to look at the system on the other side. Once my mouse comes back, did my mouse battery go dead? Ah, my mouse battery went dead. Let me get a new battery and I will be right back. But hey, at least I figured it out. And oh, hey, look, my mouse works again. Yay. Yay. We like functioning mice. So where I was going was, let's say I wanted to pivot and see what this IP address has been talking to. Once I've highlighted it, I'll get the little P showing up here. And now when I click that, it switches the screen so that that IP address becomes the center of the circle. And I can zoom in, I can move stuff around. I can see, oh, hey, what did communications look like with that system? What were we resolving in order to be able to get there? Anything in white, that's probably okay. Anything in orange, it looked a little off. It might be what's generating all the threat points. It might not. It might even be something you've safe listed in the past. Here we want to show you everything. So you get an awful lot of detail about what this system is communicating with, again, with perspective to the other side of the firewall. So this won't show me any of the other internal systems this might have been talking to. It's only showing me stuff that's out on the internet side. Let's see, long connections. This one's pretty easy. Notice pretty similar setup. Oh, one thing I didn't show you was that not only is there an investigation menu on the external side, there's also one on the internal side. It's limited, but what's nice is in the enterprise version, you can modify this. So if I'm using an elk stack to go through and record log entries for my internal systems, I could add my elk stack to this menu. And now when I click on it, it will jump into my elk stack and it will, load up this IP address as a search parameter. And now I can go look at all the logs that was being created by that system. Let's see. What have I missed? See, we talked about that. Oh, if you're in the VM and things are kind of scrunched together, sometimes playing around with the zoom will fix that. Your best bet is to just go full screen. Go full screen with the VM and everything will line up fine. But if you need to run it in a small little box for some reason, playing around with the zoom will help fix that. Oh, database selection. I didn't show you that. So the way to change databases is up here is this little gear icon. If I click that, database is highlighted by support by default. So I can go in and I can change to any database that I want to go through and see. If I need to manage the databases, let's say I didn't need this database anymore, I could just click the little X. I can also go in and do it by age. So by default, with the enterprise, the community edition only keeps the last 24 hours. But with the enterprise edition, you can keep the data as long as you want to. So it's worth it to kind of go in here on occasion and say, hey, anything older than 90 days is probably okay. I don't need to keep that around anymore. So you can just go in and quickly nuke that if you need to. Safe listing. So I can go in and I can manage my safe lists. If I click the view edit screen, I'll see any safe lists that are there currently. Let's see, where's the OneNote one I created? This is the one we just created together. Was the OneNote entry. So I can go in and if I end up with a lot of safe list entries, I can go in and do searches under different types, what IP ranges or source of destination they might be associated with. So this allows me to go in and kind of manage these if I want to. I can also export them, import them back in again. It's a good way to back them up. I can also nuke them. So I'm going to go through and remove all of mine because some of those are actually ones we're going to create as part of going through and doing the labs. There's also different themes you can choose to load up. There's DaVinci mode, which is kind of light. Some folks prefer this one a little bit better. Some folks really, really hate this because it's just kind of bright for them. They like the dark mode better. Pick and choose whatever it is you want to go with. That because if you don't like it, hey, just come back here to themes, go back and select the other one. You're back and run into the races with the other one again. Let's see. Brenton, how come the database is not in MySQL format so it's portable? Is this a proprietary decision? Just wondering. So, Kavgar, good question. So back before I started with active countermeasures, back when it was offensive countermeasures, and I got the damn name change because, oh my God, you don't want to name your company offensive. That's just a bad idea. The choice was already made to go with Mongo. And I think the reason the choice was made to go with Mongo was because Mongo, works with documents and data sets. So they kind of looked at that and said, well, we can have our data set of documents be a 24-hour period of time. Once we rotate that, everything is always within its 24 hours. And hey, this works out great. Mongo's great for unstructured data, but what we're processing really is structured data. So it's probably not the best backend for this. So with that said, we're actually currently in the process of changing the backend. We're going to ClickHouse for our backend instead. And some of the initial testing we've done has shown, Bill or Keith might remember off the top of their heads, but I know it was is at least like a 10x improvement. We were seeing situations where, a big amount of data, having Mongo try and import that and process it to see if there's any beacons or anything like that. It might have taken, for a specific data set. I remember one of them, Mongo was taking almost an hour. Right. So it's like right on the cusp of what we could barely handle because this tool is importing all this data once per hour. And then it combines that with the previous 23 hours to look at a full 24-hour picture. And then the next hour it does it again. And the next hour it does it again. So if it takes more than an hour to import the data and process it, we start running behind. And there was a data set we have that with Mongo, with a nicely spec system, it was taking almost an hour. And when we switched over to ClickHouse, that dropped down to like 3 minutes. I mean, it was just insane, the difference between the two. So to your point, Kafka, you're right. It should not, Mongo's probably not the best bet. We're switching over to ClickHouse. That's going to make things run a whole lot smoother for us. In fact, I tell you what, if folks want to stick around at the end, I'll give you a little look-see at where we're going with the front end because we're changing that too. The devs will probably hate me for giving you a quick peek, but yeah, they got to deal with it. They're used to me being a pain in their backside. So I'll do that after the end of class so anybody who's not interested doesn't have to stick around and deal with that. All right. So we talked about all the settings. See, this is why I like having slides. It makes sure I don't actually miss anything. Safe list entries. I showed you how to go through and add those in. Talked you through how to go through and create a safe list. We talked about the summary information that you're going to get on each entry here. How to create a safe list entry. I showed you that. I showed you how to work with wildcards. When you do it based on IP, it's a little bit different. Right. So let's say I looked at this and I said, oh, alphastjameschurch.org. I know what that is. That's one of our business partners. We send them data all the time. I want a safe listed that entry. Well, we've got an IP address now instead of a fully qualified domain name to work with. So I would click on my filter icon and now I could go through and I could safe list it based on that target IP or based on the subnet it's on, or I could even do it based on a pair. This is great for things like TeamViewer, right? Where, hey, TeamViewer is okay on these 3 servers because I installed it there. But if TeamViewer shows up anyplace else, I want an alert. I want to know about that. Well, though the ones that are okay, I do those based on pairs instead. So you get a little bit more flexibility when you come in and do it based on an IP. All right. So that is that. Yeah, you might see a little safe list updating in the right-hand corner. That just means those safe list entries are getting processed. If you don't see it happen quickly in these labs, just hit Control R, reload the page, and it'll update right away. Sometimes the VMs are a little low on memory, so they don't actually clear it right away. It might need a Control R. Let's see, we talked about managing the safe lists. I already walked you through that, talked to you about how you can search through them. Community edition, you can have up to 50 safe list entries. Enterprise edition, it's unlimited. Excuse me. What else do we talked about? Yeah, we talked about beacon score analysis. We hit this. Drop down menus. We talked about that. Deep dive, we talked about that. I told you how to pivot. Yeah, we talked about this. Talked about this. Oh, with these data sets, you may occasionally do hit the investigation menu, go out to a site, and it'll say, "Whoa, this target IP address is a known malicious site." No. So all of these, so all of these PCAPs, we created in a test environment. In some cases, it is the actual malware, but we just redirected things back to servers we control. Well, we've released those PCAPs for people to work with so they know, hey, what does this stuff look like? What do I need to be concerned about? So some of these sites have picked up these things and said, oh, well, this is showing malicious traffic to this IP. Therefore, that IP must be malicious. No, no, that's just how we were going through and collecting the data. So if you see this with any of our data sets, don't get too worked up about it. It's just, they don't have the best screening process for what comes in. Let's see, Chris, should we not be very concerned by the connect to IP address string and prioritize those? Can you please explain? I'm not quite sure what you're asking with that, Kafka. Should we not be very concerned by the connect to IP address string? Are you talking about like the app layer stuff? I'm not totally following what you're saying. So, so yeah. Yeah, long connections. I showed you that screen. Data import. So let's talk about this one. So again, this is, and I saw someone saying they were joking. Okay, no problem. So this will not work if you're on one of the shared instances, but this will work if you're on your VM. So here's what I want you to do. So we said under this labs directory, this lab 1, lab 2, lab 3, we want to start with lab 1. So I'm going to say cd space lab 1. Now, if I type in ls again to see files, these are all my Zeke logs. So I did this ahead of time for you, save some time. So I took a PCAP file and I told, hey, Zeke, read that PCAP file and you log what you think you see that's in there. Oh, proxy agent, host string. Yeah. So, yeah, I don't think there's any proxy data in the one that I was working through. So we're just going to kind of skip that for these examples. But if you knew you were using a proxy, let's say you get SOCKS running, that module will go through and figure out, oh, you've got a proxy. So the fact that everybody's talking to that IP isn't anything to worry about. That's not an actual, C2 server. And oh, by the way, they're going to be communicating through it to a system on the other side. You need to analyze the SOCKS protocol to figure out what they're trying to get to. So that's what that module is for. So let me show you an example of the data that Zeke produces for us. So here's the command I'm going to use. Less, L-E-S-S, space, dash capital S. So by default, actually, don't do this. Let me just show it to you. Less con.log, right? So this is all the data that's in there with less displaying it. Notice everything's line wrapped. This is really hard to read. So what I'm going to do is I'm going to change my command to make it easier to read. So dash S says, do not line wrap. Rather than have things wrap around like you were seeing it doing just then, I want you to extend the data off the end of the screen. So now if I run this, and again, don't do this. I'm going to give you the final command in just a minute. I just want to show you the progress as we go through. So now when I run this, notice everything's in nice little columns, right? Well, except for here. Notice I've got an IPv6 address that extends in. So some of this column is here, some of it's over there, but you can see this data off to the right. See the little arrows here? What that's telling me is if I hit my right arrow, I can actually navigate over to see that data. But again, everything's all kind of mucked up because my IPv4 versus IPv6 kind of messed with everything. So the way to fix that is dash capital S dash X. I can go through and define how wide do I want each column to be? And I'm going to just pick 50, just because I know that's going to be bigger than my IPv6 addresses. And then say the name of the file. So this is the command I want to use if I want to go in and poke around at any of these files. So now when I hit enter, notice I've got a lot more white space in here, but I don't have the problem where this is causing this data to shift off to the right and be out in a different column versus everything else. So it makes it a little bit easier to work with. Remember with Zeke, I was telling Zeke, hey, I want to see specific fields. Where did I get those field names from? Well, they're all right up at the top. So like id.org_h, that's my source IP address. id.org_p, that's my source port. Well, wait a minute, Chris. The title is for the IP source IP address is here, but the column's over here. Yeah, here's why. For some reason, Zeke needs to print fields at the beginning of the line. And because they do that, everything gets right shifted and it doesn't match up with the actual column. I hate that they do that. I think we can figure out those are field names. I don't think we need that at the beginning. And if they chose not to put that in there, everything would line up nicely. So that's why you see everything getting right shifted like that. But this is every single line here is one connection that took place on my network. So rather than having a bunch of packets, I just have a single line. Now notice that the service column, which is this one, is identifying the protocol that was seen. So anytime it couldn't recognize the protocol, this con.log entry is the only thing I'm going to get. But anytime it recognized the protocol, like it saw HTTP, it saw DNS, that's going to give me, now to get out of the screen, I'm going to press the letter Q. And that'll, I've got a little double colon down here at the bottom with a flashing cursor. When I hit the letter Q, that gets me back into my command prompt. But I saw there was HTTP traffic and I saw there was DNS traffic. Well, there's additional information in the DNS.log file and the HTTP.log file, this one here. So if I wanted to, I could even go in and look at those. So if I wanted to say, hey, let me check out what's in the DNS.log file. Okay, so this is showing me times these queries took place. This is Zeke's unique identifier. What this does is this allows me to map this connection across multiple files. So there will be, this ID number will exist in con.log to show me that information, but it also exists here to show me the specific DNS information that's associated with it as well. So it's showing me the ports that was used. Oh, this is multicast data here. So that's why it's all desktop, local, blah, blah. But you can see as I go down, I'm getting some real DNS names in here now. Settings-win.data.microsoft.com. So, here's all my queries and I'll have my answers in here with it too. Now, we want to take, and this will be the last thing before we go on break again. So we've got these Zeke logs. We want to bring these Zeke logs into AC Hunter so we can use AC Hunter to go through and analyze it. The way we do that is we use the Rita command. So I'm going to say Rita, R-I-T-A, space, I got to tell it I want to import data. Okay, what data do I want to import? I want to import all the log files in the current directory. That's what the star.log does. And then I need to tell Rita, okay, when you import this, what do you want to name the data set? Well, I want to name it lab 1, right? We'll put the lab 1 in the lab 1 data set. We'll put lab 2 in the lab 2 data set. We'll put the lab 3 in the lab 73 data set. No, I'm kidding. We'll put it in lab 3. We'll keep it consistent, but you get the idea. I'm going to throw this into the Discord channel. So everybody's got that exact command. So you can copy paste to make sure you get the right one. And then I'm just going to hit enter, and it's going to prompt me for a password because this needs to run as a high level command. My password is hunting, Hunting. Again, anybody who's on the shared instances, you can't do this, but this has already been done for you. So you should be able to go in and just select the Lab 1 data set. So notice this goes through and gives me a summary of what was seen. Now, once that's done, now I should be able to go to my AC Hunter interface, go to my little gear icon, and oh, look, we have a new data set we didn't have before, Lab 1. I'm going to confirm to load it. Now, if you're on the shared instance, you may see a couple of additional IP addresses listed here, but with a score of 0. Don't worry about those. But we've now gone in and we've now loaded up that data set. So it is top of the hour. Let's see. I apologize due to my limited knowledge. A way to freeze the top. Oh, is there a way to freeze the top row column as well at the command line? Oh, good question, Kafkar. So first of all, don't apologize. We all start somewhere. We all learn new stuff. So I pick on Bill a lot, but I'm going to let you in on a little secret. I constantly try to teach Bill new things about Linux, and I constantly fail. There was a period of time that I used to have a whiteboard where I would actually write on the whiteboard things I've taught Bill Stearns about Linux that he didn't already know. I've known Bill for over 20 years. I don't think that list ever made it past 7 or 8. I finally just gave up on the whiteboard at that point there, but you get the idea. We all start somewhere. We all learn things, you know? So to ask a question because you don't know, absolutely nothing wrong with that. Now, with all of that said, is there a way to freeze those columns on the top? Not that I can think of, but Bill, if you know a way to do that at the Linux command line, hey, go for it. But I don't think you can do that with the less command. So you have to kind of scroll back up to see what columns were what. All right. With that said, let's take a 10-minute break. When we come back, I'm going to have labs for you to do. So I will catch you then. I have taught Bill absolutely nothing. Awesome. All right. I will catch folks in 10 minutes. All right. We're back. So there was some talk about, encrypted DNS. Just say no. Bad idea. There's DNS over TLS. They're tunneling DNS queries over HTTPS. Both bad. Say no. Get that shut off. Oh, but Chris, it improves privacy. No, it doesn't. No, it doesn't. I am so sick of that argument. The browser vendors tell you it improves privacy because the ISP can't see your DNS queries anymore. But guess who can? The browser vendors and the people that they're sending their traffic to that they're getting a cut from. So it isn't that your data is more private. You've simply moved who can actually harvest that data from you. That's all. What you have done is you've blinded the local environment from being able to use that valuable DNS data in order to help keep the environment safe. So if you want to use it at home, hey, your call. Do whatever you want. Within a corporate environment, I would highly recommend you don't let DNS over encrypted DNS take place because you lose a lot of visibility that way. And yes, I did mean it. Bill's wife can totally kick his ass driving in the snow. I trained them both. I know. Sorry, Bill, but it is what it is. Yeah, she can 100%. Yeah, so at least he's willing to admit it. Awesome. Second time today, I'm jump scared by Chris saying, all right, after 10 minutes of silence. I try to come in quiet. I do. I honestly do. Because I do recognize that you've had like a lot of silence, and a lot of times you forget the headset's even on. And then all of a sudden, woo, there's my voice. So yeah, want to make sure that I do try to come in quiet anyway. So all right, so we imported that Lab 1 data. These slides just walk you through the process, so you've got that recorded in case you need it. Someone was asking about compressed log files. Will Rita import those? Absolutely, it will. Absolutely. If they're in gzip format, it'll happily pull those in as well. You'll see the lab one data set up here. We got that. All right. It is lab time. So we're going to take the training wheels off a little bit, and I'm going to let you kind of go to town on this one. So in the first lab, what I want you to do is I want you to go into the Beacon Web module. So click the little icon down at the bottom. Don't follow in from above. Um, although honestly, it doesn't matter. But you've got 6 entries that score above 80. So let me show you that. So if I go into Beacon Web, there's a little color code here. It's kind of hard to see though, especially with the dark background. But it starts off red, goes to orange, goes to yellow, and then it may eventually go to green, depending upon what data you have in there at the time. This is based upon what the score is. So anything that's in red scores a high score for persistency. As you drop down, the values get lower. I like to go in and look at anything that's 80% or higher. So that would be orange or red. Anything in orange or red, that's something I want to go in and pay attention to. And we have 8 of them here. So what I want you to do is I want you to spend about 60 seconds looking at each of these entries. Actually, there's 6 of them, not 8. So I want you to spend about 60 seconds looking at each of these 6 and identify, does it look suspicious or does it not? I don't want you to, you don't have to go down a rabbit hole on this. And I don't want you to feel like, oh, this needs to be a 100% definitive answer. No, I want you to click on the first one, look at the data being presented, and say, am I feeling more like it's evil, or am I feeling more like this is something we can add to a safe list entry? And then we'll go through and we'll talk about those. So I'm going to go in and I'm going to go on mute while you do this lab. I'm going to give you a couple of minutes to work through it. And then we'll go through and we'll cover this together. And I will try not to come back in and say, all right, too loud. So just as reminders, we are working with the lab 1 data set. So when we use DNSCat 2-JA3, that was just to kind of show you around. You should now be in the lab 1 data set. This is a lab, so I'm going to let you work through this on your own without me kind of hand holding you through, but we will certainly cover what you should find at the end of this. So I'm going to give you a little bit more time to go through this. Let's jump in and let's talk this one through a little bit. Since it's our first lab, I want to make sure that, folks aren't kind of getting frustrated with what's going on. So we said we wanted to go into, I believe it was Beacon Web, right? Yep, we want to go into the Beacon Web module. And we said there are 6 entries, 1, 2, 3, 4, 5, 6. So 6 out of the 7 have a score of 80 or higher, and we want to run these down. And I said, you don't have to go too crazy on this. I said, don't spend more than a minute on it. And one of the things I throw in the hint is if you look at it and you're not sure, go to the next one, right? Because if you can, figure those other ones out pretty quickly, then you can go back to the ones that were a little bit more of a challenge and kind of hit it from there. So let's kind of talk about this first one here. So this first connection is going out to this 104.248 IP address. Now, notice it's going to an IP address. We're in the Beacon Web module. What this is pulling out is the host parameter information that is inside of the HTTP header. That should always be a fully qualified domain name. It should never be an IP address. So if I look at the other entries, see, fully qualified domain name, fully qualified domain name, fully qualified domain name, IP address. No, that's wrong, right? So the host parameter is there because I might be running multiple web servers on the same physical box, and they all have the same IP address. So I need a way to specify each of the different virtual servers. Well, the way I do that is with the host parameter. And this is not doing that. So that's highly suspect to me that this is taking place. If I look at it's a GET request, TCP, it's got an HTTP header. Look at our user agent, Mozilla 4 Windows 7. Huh? This is a Windows 7 box? Does that make sense? Let's take a jump over to client signature. So if I look at my client signatures, I can see that this 192.168.99.51 Wicca agent, okay, that's encrypted traffic using Windows 10, Windows 11, Microsoft Crypto API 10, that's Windows 10, Windows 10, Windows 10, Windows 7. That's not right. Something's wrong. And there's 311 connections going to this one IP. Here we're seeing multiple connections. So the fact that it's now, the only time it identifies itself as Windows 7 is for this connection. Oh, that's really suspect to me. If I look at this graph on the bottom, you can see I've got a connection going off about every 30 seconds or so. We're seeing about 120 connections per hour. It's not perfectly flat, but oh, it's really close to it, right? 3,011 connections over a 24-hour period of time. That's a lot. This one's suspect to me. So I look at this one and say, okay, I want to dig in a little bit deeper, but I'm not getting the warm fuzzies on this one. Go to our next one. So this one is going to array56.prod.do.dsp.mp.microsoft.com. Okay, cool. The S&I information. Who was this digital certificate issued to? Notice it was issued to star.prod.do.dsp.mp, blah, 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 blah. So this is a wildcard digital certificate that's been issued to anything through any host attached to the subdomain prod. Invalid certificate. Yes. Now, I threw this one at you this way for a reason. So if you looked at that and you said, whoa, wait, the digital certificate's invalid, that makes me suspect. Perfect. Your security. However, this is Microsoft messing around. So what Zeke does is Zeke uses the certificate store in Linux, which includes all the well-known certificate authorities, to go out and check this digital certificate. What Microsoft did is they said, well, this is, the only thing that'll talk to this address is a Windows system, and we own Windows, and we own the backend. So we're going to create our own digital certificate, and we're just going to throw that digital certificate on all the Windows systems we distribute so they know to trust us. And we won't use the certificate authority. We're going to sign this ourselves. We're going to sign these ourselves and do it that way. Well, you can kind of see why they did this, right? I mean, Microsoft is a lean startup company. They don't have a lot of revenue to work with. I mean, these digital certificates are expensive. It would have cost them like $300 to buy a certificate from a certificate authority to have it on here so that the certificate should always be validated. Microsoft can't afford that. They're going to lose a couple engineers if they have to pay $300 every 2 years for this digital certificate. So to save some money and run lean, they decided to self-sign their digital certificate. Yes, a lot of you would get it. I'm being totally sarcastic. This was stupid. This was a dumb thing for them to do. I understand the logic, but they forgot about people use tools to check this stuff, and those might not necessarily run on Microsoft. So what do I do? Here are my options. My options are figure out where Microsoft has decided to use self-signed certificates and just hope for the best. That's one option. Option two is I can get a copy of that digital certificate of the certificate signing authority, and I can actually add that to the Linux certificate store and go through and do it that way. And once I do that, now my Zeke process, which is using the Linux certificate store, will look at that and view that as being a legitimate digital certificate that it can go off and validate, and that will change this value to no. So I threw this curveball at you because you're going to run into stuff like this. So, it looks invalid, but we need to do a little homework just to make sure, because the rest of this is looking like, this might actually be okay. So knowing that, we'll assume this certificate's okay. This one's probably fine. Let's see. I saw a question scroll by. See, Brenton, filter the score to greater than 80. Yep, you can do that. Absolutely. So I have it filtered to 50 and above because that's default. But I could go in and say, show me 80 or above only. And now I'm only seeing the ones that I need to be concerned about. So absolutely. Yeah, there's a lot of different ways you can go through and kind of cut this stuff up if you need to. All right. So the second one we're looking at, this one's probably okay. We could probably add this as a safe list entry. I look at the third one, tileservice.weather.microsoft.com. Okay, that's a known entity. It's a GET request. It's a Windows 10 user agent string. It's going to, oh, look at that, a lot of IP addresses. We only print out the first 20, right, or so, right? Notice the end of it, it says truncated. So instead of it being a lot of IPs, this gets reclassified to a boatload of IPs. But you get the idea. They're all, these are all CDN systems that are front ending the traffic that's going back to tileservice.weather.microsoft.com. So what does this do? Well, we could do some research on it, right? I could go in and I could go to Virus Total, see what Virus Total knows about it. If I did a little bit of Googling on it, that would tell me that Microsoft Weather Services. So what this is, if you're running a tiled desktop and you have, one of your widgets is the weather system, it will go off on a regular basis to check to see what the weather is, specifically every 30 minutes. So we could look at that and say, oh, okay, now it's not business related per se. Well, maybe it is. You could say, oh, well, this lets people know if they're going to be able to commute and have it be safe. Yeah, okay, fine. Whatever argument we want to make. Is this malware? Yeah, well, that's arguable, right? But is this unsafe? Yeah, I think we're okay on this one. So this is another one I would probably go through and just add to I would add to a safe list entry. Okay, let's look at the next one. The next one, ooh, array 509. Didn't we see that before? No, we saw array 506. So array 506, array 509. So if I go in and create a safe list entry, we're not going to do it yet. This is actually going to be our next lab. But I may want to enable a wildcard search and say anything above prod is okay, because I've now seen there's at least more than one. The other reason I would do that is if I look at the digital certificate, it's been issued to anything under the prod subdomain. So I like to make my safe list entries kind of match the digital certificate, because if it's a wildcard cert like this one, there's probably going to be multiple hosts, and I don't want to have to create a unique entry for every single one of those. So that one is probably a safe list entry thing. ctldl.windowsupdate.com. This ends up being another one that looks like, yeah, this is okay. This is our systems going in and kind of patching themselves. Our last entry, array 503. So now we've got 3 under prod. So all of these look okay. So just a quick run through. Our last 5 we looked at, we said, these look okay. These we can probably go through in safe list. This first one, that's not a safe list. There's too many weird things about it. There's a lot of connections taking place. The host parameter is an IP address instead of a fully qualified domain name. It's claiming to be Windows 7, but we also know most of the time this system is claiming to be Windows 10 instead. So there's a lot of suspect things here. This is one we definitely are going to want to go down the rabbit hole on. All right. So let's see where that leaves us. Did I miss anything? So yeah, high score, a lot of connections on the first one, Windows 7, all of that looks really suspect. So this first entry, yeah, I'm suspicious about this one. This is one I'm going to want to pay more attention to. Second entry, we said looks okay. Third, fourth entries, yep, these look okay. We said, hey, we're getting multiple under prod. So when we get around to creating a safe list entry, we're probably going to want to use a wildcard for that. And then we looked at the last 2, and these looked like they were okay as well. So here's what I want you to do. I want you to go back into this list and create your safe list entries. So we said this first one, suspect. Don't create a safe list entry for that. But go to your second one and start working your way down and decide what's the best way to go about creating these safe list entries. This should be a pretty quick one for you. So I'm going to give you a couple of minutes to go through this, and then we'll cover it together. And I'll be on mute while you're working on your lab. Okay, so just a reminder, if you're working with the shared instances online, you can't create these safe list entries. Those instances are specifically designed to be read-only, because we've had problems in the past with people deciding, oh, hey, let me mess with everybody else in the class by deleting the data set. That will be fun. I will be a jolly joker, or I will create safe list entries that shouldn't be created so people can't see the data they're trying to work with. That will be funny. So we've had enough problems with that we've had to make these instances read only. So on the plus side, that means you don't have to worry about people hiding data from you by creating safe list entries that you don't know are there. You also don't have to worry about people deleting the data sets. Unfortunately, that means there's a couple of functions that you'll be able to watch me do, but you won't actually be able to do with the online instance, like create these safe list entries. So that's why you may be running into that. Okay. So creating our safe list entries. We said the first one, we definitely don't want to safe list that. We want to spend some more time looking at it. So I'm going to go to my second entry. My second entry is array506.prod. So we said, okay, we actually have multiple that have that problem, or that multiple that show up under prod. So I'm going to enable the wildcard. I'm going to have that match what the digital certificate says. And had this been production, I would have said, "Hey, see, Brenton made this entry on February 23rd, 2024, and here's why that entry was created." I'd put some sort of comment in here. I'm going to skip that for now, but I'm going to go in. I'm going to create that safe list entry, and then once I do, my data gets updated, and now my other prods go away. It hit all of them at the same time. So this one, tileservice.weather.com. I could use a wildcard here. I don't think I need to. I'm not aware of anything besides tile service that shows up under weather. This is a TCP/80 connection, so there's no digital certificate. So we can't use the digital certificate as guidance to figure out what might be here. So I'm gonna, when in doubt, play it safe. I'm just going to create this to impact tileservice.weather.microsoft.com. Well, Chris, why don't you just go in and do a wildcard for all of Microsoft.com? You could. It'll work. The challenge you run into there is if there is ever a rogue system set up under Microsoft.com, you've now defined that as being a trustworthy system. You'll miss it. So with our safe list entries, we want to think them through and we want to be careful. One of the things you also want to make sure you never do is create a safe list entry based on IP addresses that are content delivery networks. Because remember, anything can pass through that content delivery network. It could be Microsoft, it could be evil. And if you say that IP is always trustworthy, well, now if you get whacked and they start using, that same CDN to funnel their C2 traffic through, you'll never see it. And I have seen folks do that, unfortunately, in the past. The good side is when you create these safe list entries, we don't delete any data. The data is still there. We just don't show it and we don't score it. So let's say 2-3 weeks from now, you figure out you created a safe list entry that you shouldn't have. Delete the safe list entry, go back to the data from the date that that thing was created, re-review your data along the way, and you'll see what that data would have looked like had that safe list entry not been created. So I'm just going to do this for tile service weather. My next one, ctddl windowsupdate.com. So again, I'm going to go through and I'm just going to do one for that entry only. And then I got a last one here, settings-win.data.microsoft.com. It's TCP/80. This is issued to windata.microsoft, settings-windata.microsoft.com. So this one's not a wildcard. This one is issued to this specific system. So knowing that, I'm going to do a specific entry for just this one. So I won't use the wildcard for this one here. So I've gone through and created like 3 safe list entries, I think. Let me double check. But that's taking care of all 5 of those entries. Yep, here are the entries I've gone through and created. So I got 4 of them created. Cool. Go back to Beacon Web. So now I've only got just that one. How long do we remove a safe list? How do we remove a safe list entry? Good question. Let me show you that. So I'm going to go up here to settings. I'm going to go to my safe list. I'm going to say view edit. And let's say I didn't want this prod one for some reason. click the little X over here, and that will delete it. That's how you get rid of them if you didn't mean to create them. And I always get a little summary of how many entries I have here. And you'll even get that in the screen. See, oh, I just noticed we use a filter icon here and here. Well, it's all part of safe list. So that, yeah, actually that makes sense. But notice I've got a little number 4 here. So what this is telling me is when I had no safe list entries, this icon did not appear. Now that I have safe list entries, it's there as a reminder to tell me you're not looking at all the data. There are entries being hidden from you because safe list entries have been created. Okay, see if I missed anything. Potential bug found. I can add comments with special characters. But when I was editing the comments after it complained about it, no special characters. Oh, hey, Bill, make a note of that, please. Make a note of that. Good catch. Thank you, dude. So yeah, so we went through, we created some safe list entries. I talked about how to make wildcard entries. That one entry removed all 3 of those at the same time. Here's the 4 entries that were created. Oh, I've got edge.skype.com on here. I don't think we didn't actually remove that as part of this one. So that was one that was created earlier. So you won't have that. Don't worry about it. So that got rid of everything but that one connection. So we're going to move off of that for now. We'll come back and reevaluate it. But we haven't looked at long connections yet. So let's go in and take a look at our long connections to see if there's anything we need to be concerned about. We want to evaluate any connection that's lasting longer than 5 hours. Anything that's been persistent for more than 5 hours is a long-term connection. We want to evaluate that to see, is there a potential business need associated with that? So I'm going to give you a couple of minutes to work through this one, and then we'll go through and we'll cover it together. I'm going to go on mute while you do the lab. Okay. So let's go through and talk about this one. So in this one, we wanted to go through and review long connections. So that's this module down here at the bottom, which actually I know this sometimes cuts off in Zoom. Let me make my screen just a little bit smaller so you can see what I'm clicking down here. So we're going to go to the long connection module. And I said anything that's more than 5.5 hours is worth evaluating. That's the default filter. If I open it up, I can see there's a bunch of other stuff in here too. But what I'm most worried about is anything that's lasting 5 hours or more, so we can leave it at default. So we get a couple entries here. This first one is going to a non-standard port, TCP 9200. Now notice it doesn't recognize the application layer. So this is a problem with this version of AC Hunter and prior. It's something we're fixing in the next one, which is that if the connection has been running for more than a day, we tend to kind of forget what was actually looked up to have these systems show up at that address. That, like I said, that's something that's getting addressed for the next version. So we lose the fully qualified domain name that may have been queried, but it's also in that initial portion of the connection that the protocol that's being used gets identified. So this may have been DNS, this may have been HTTP, it may have been, SSL/TLS. And it may have recognized that initially, but we can't tell anymore because it's been running for more than 24 hours. And we could see here the duration of the data set here is saying, yeah, it's been running for at least 24 hours. So that stuff's gone missing. It's going to DigitalOcean. So one of the things I could do is say, well, let me do some investigation on this. Let's see what VirusTotal knows about it. So VirusTotal says that this is associated with AIHhosted.com. I wonder what that is. So what I would do, I would not do this. So remember, one of our rules with threat hunting is don't cross the active passive line. Don't do anything the attacker can detect. But there's some active things that we could do that there's no way the attacker is going to detect. And one of them is when we get a domain like this, we may just want to go visit the website. Now, I would not do it from the domain that I'm currently evaluating. I would, go home and do it from my cable network, do it over my Verizon phone while it's not connected to the local wireless, something like that. But connecting to a website, you can argue, well, but they'll see somebody connected to their website. Yeah, no, they're going to see thousands of connections per day. TCP port 80 is one of those ports that just gets beat up on all day long. Anybody who's run a web server out in the wild knows that you constantly have people hitting that port. So let's pretend this tab is my cell phone off of wireless connecting through AT&T. Oh no, wait, that doesn't work anymore. So Verizon, and I'm going to go to www.aihosted.com and see what comes back. Oh, active countermeasures. What's this? I don't know. Hey, purchasing department, has anybody purchased something from active countermeasures? You guys got that, right? The AT&T thing? Yeah, I don't know how many folks have like heard what happened yesterday. Um, Long story short, AT&T is moving their core backbone to Microsoft's Azure because, hey, nothing ever gets compromised in Azure anymore, right? That, not over the last hour anyway. But yeah, they're moving their core infrastructure to Azure. They're also moving from a hardware based to a software based networking. So in the past, if they went, if they were at a pop and they were going through and doing an update, that would impact that local area. Well, it's all software now. So changes tend to propagate and cause problems over multiple areas. Oh, I hate it when that happens. The funny part of this is Microsoft did an agreement with them to build this. They want to be the backbone for all cell phone providers. AT&T was the first one to sign up. And they basically bragged about, hey, yeah, we don't know what we're doing, but we're going to learn in production as we go. And once we learn on AT&T, we'll start offering this up to other vendors. So I'm sure Microsoft kind of sat back and said, wow, everything blew up. Wow, that really sucks. Yeah, okay, we'll know not to do that with anybody else. Sucks to be you. Was it Microsoft who pushed out a wrong update? Was it AT&T? I honestly don't know the answer to that question. But I will say I'm kind of surprised it's taken this long for this to actually happen. So that's what kind of happened with the whole AT&T thing yesterday. But to come back to this, so we went to www.ahosted.com, from our Verizon phone not connected to wireless, and we ended up here at Active Countermeasures. Now we might want to go to the purchasing department to find out, hey, are we buying services from them? And we may find out, yes, we are. There's this service we're buying with them. In which case, once I know that, now I know this entry is okay. This is something that could be safe listed. If I don't find that out, okay, now I got to keep going down the rabbit hole to figure out what's going on. What I might do is say, okay, let me see if I can't figure out what application is running on that system. Is anybody else talking to that target IP address? If not, okay, it's just this one box. Now, what app is creating this connection? Why is this taking place? I might start going down the rabbit hole. I might even push the little red incident response button and say, hey, it's still questionable whether we're compromised, but this looks highly suspect. We're sending data to this organization and we don't have a PO with them. We're not buying any services from them. And we're not sure what data is actually getting pushed out to them. So maybe we go into incident response mode to figure out if we can't run this down a little bit further. Our second entry, TCP 443, it's not identifying it as SSL. But again, if it's been more than 24 hours, that we lose visibility on that. So we don't know what was queried to get there. This is going to something in the Microsoft domain. It's going to ASN 8075. So go back about 2 years, and 8075 was used to be considered quote unquote safe. Microsoft basically said, hey, anything that's part of ASN 8075, that's our backend servers. That's managed by Microsoft and Microsoft alone. We manage security on these. We will make sure these stay locked down. So when you saw something going to 8075, yeah, you're probably okay. Then there was an environment there was an environment that set that up as a safe list, which one of the other changes we're doing in the next release is you can't safe list an entire autonomous system number anymore. Um, but what they did is they safe listed um, that ASN, and they had hired some red teamers. Um, Probably shouldn't say who, PHS. And one of their savvy red teamers figured out how to spin up an instance in Azure and have that get routed through 8075. So it looked like this instance was running within Microsoft's trusted environment, when in fact it was a public VM that anybody could spin up. Ooh, I hate it when that happens. So there used to be a time when you could say, oh, 8075, this is probably okay. But the reality is, yeah, I wouldn't like trust that anymore. So again, we could go to Virus Total, we could go to a couple other places. One of the things I want to look at is the history here, right? So what has this IP address been associated with? Well, cloudapp.azure. Okay, that's Microsoft. Trafficmanager.net. Okay, that's Microsoft. Windows.com. Okay, that's Microsoft. Traffic Manager, Windows. So it looks like this has been an IP address under the control of Microsoft for a long time. So this is probably going to be okay. So this is another one I might consider going through and creating a safe list entry for. All right. Let me shut those. Let me see if I missed anything. So basic, yeah. So I talked about, after 24 hours, data gets lost. We're replacing that. And again, at the end of, so once we finish today, I'm going to give folks a quick preview of where we're going with the tool if you're interested in seeing it. If not, labs and everything will be over at that point. You can drop and not miss anything. If you're really curious, I'll like show you some stuff that'll probably like bum my developers out that I'm showing off in public. But hey, everybody here seems cool. I haven't seen anybody in the channel that I feel like is kind of a pain. So hey, let's go ahead and we'll go for it. But that'll be after we finish class. So yeah, we talked about this one. We may want to go look it up from outside of our network. Talked about the second one. Looks like it's part of Windows. Um, so to kind of sanity check where we're at now, we had 5 beacons we said are probably okay. We had 2 long connections that we said we're leaning towards okay. They're probably going to end up being all right. So there's 1 beacon left that we're really worried about, and that's it. So what we're going to do is we're going to go through and we're going to do a deep dive on that when we come back. So what that means is I want you to see how much can you learn about that system. Is this something we really need to be concerned about or not? But we will do that when we come back. So it's the top of the hour. We're going to take a break until 10 minutes after the top of the hour. We'll immediately jump in and start doing this lab. All right, we are back. Does AC Hunter support running ERR roles meant to be run against the network packet captures? So no, it does not. We're not looking to do any type of signature matching or anything along those lines. The tool is strictly behavioral based. Now, this next lab, let's do this as a hands-on walkthrough because quite honestly, we've already kind of talked about a lot of this stuff already, right? So this first one, we were kind of talking about what makes this suspicious. Why was it we couldn't just immediately say this is okay, it's safe listed? And there's a bunch of different things on here that stand out for me. We're seeing 120 connections taking place each hour all day long. Okay, that's a lot of traffic. That's every 30 seconds. There's a lot of connections taking place. I can see a little bit of a variation here in some of them, so that tells me there's probably some jitter being introduced. Very high persistency score. 3,000 connections over the course of the day. That's a lot. When I look at what time intervals are being used, some of these are going off at a 27-second interval. Some of these are going off at a 30-second interval. And then we have one connection that's 33. We have one way out here. That looks more like an outlier to me. So it's a fairly constant, just under 30-second beacon signal that's taking place. But we got a lot of them going by here. I mentioned up here, this should be a fully qualified domain name. This is the host parameter within the HTTP header. It should not be an IP address. That makes it suspect. I mentioned the user agent string. We went and looked and we saw that most of the time this system claims to be Windows 10. This, when it talks to this one system, is the only time it identifies itself as being Windows 7. That's highly suspect. If I go in and look at the data distribution, I've got what looks like a heartbeat here. I have a majority of the connections. This looks like it could be, do you have anything for me to do? No, go back to sleep. I've got some connections taking a place above that are just a little bit more data. This could be a little bit of network probing taking place here. I've got a couple of points out here that if I mouse over them, we had 1,300 bytes. Okay, that's not a lot. That's still like you could fit all that in a single packet. So I don't think if this does turn out to be C2, we haven't got into their exfiltrating data yet. That's good. But it does look like they're starting to poke through this connection a little bit and try and poke around a little bit. So this is something we would want to respond to quickly. So what makes this something worth paying attention to? All of those attributes, the high score, the number of connections, the bogus user agent string, the bogus host parameter. Anytime you see things that are obviously forged, like the user agent string and the host parameter, that immediately sets off warning signs for me. All right, let's see if I missed anything. You say this could be a heartbeat, this could be this could be that. Why not add such a hint into the ACH? Hey, great idea. In fact, one of the changes we're making, and I'll show this at the end, is we're adding hints to be able to throw in comments like that to everything. So, yes, that will be part of the next version. So the user agent string, we talked about that. Session size analysis, yeah, that looked like C2 as well. What does Zeke show for a payload? So we could go back to the Zeke logs and say what is Zeke showing is taking place in those HTTP headers. That's something we could choose to dig into if we want to. Would you be able to tell if data was exfiltrated with AC Hunter? Yes, you could. So what we were talking about was this here, right? So we said, this is our heartbeat. This is our, do you have anything for me to do? No, go back to sleep. Do you have anything for me to do? No, go back to sleep. When that command set changes to something else, the size changes. So for example, we have 108 connections here that is 724 bytes. Now, what was that? We don't know. And quite honestly, even if we had raw packet captures, we'll probably still not know because it's probably encrypted. At the very least, it's heavily obfuscated, so we won't be able to see what's inside of it. But based on the size, we can make some assumptions. This is only 724 bytes of data. So that's not moving files. That is, I'm looking to see what directory I'm in. I'm looking to see what this user owns. I'm looking to see if I can, probe try a couple of common passwords with a login name against the domain controller. This is simple probing that's taking place here because these sizes are so small. Now, if I had entries out here that were like, 20 megs, 50 megs, maybe even like 5 megs, that could be file movement. That could be actual data that's getting exfiltrated out of the environment. Good question. So, yeah, we saw a bunch of stuff that said, yeah, this is something worth paying attention to. So, I talked about this possible C2 activation. This is our heartbeat. Um, I went back to the raw DNS logs to see, did we do any queries that had anything to do with this IP address? And there was none, which means that there was absolutely positively no DNS lookup done that resulted in this IP address being returned. So nothing was done over DNS. That's suspect. Because again, the way this normally works is you type a name in the browser, DNS resolves it to an IP address, you connect to that IP. And that's clearly not what happened here. Now, if I get into the payload analysis, now with this version of AC Hunter, this is something you need to go back to the Zeke logs for. We are incorporating this into the main interface though, so you won't have to do this. But this is showing you where in the data output it's identifying, the host parameter, which should be a fully qualified domain name, Windows 7, we look that stuff up. We saw this within the AC Hunter interface that this is the only time it's identifying itself as Windows 7. This is the one you can't really get out of the interface right now, but you will with the next version, which is what was the URL they were going after? This was the URL they were going after. And in fact, they queried that same URL 3,011 times. That is suspicious because that's common C2 communication characteristics, right? It queries for the same thing over and over and over and over again. That never changes. Well, if this was somebody just browsing a website, we would expect to see the URL changing, as they follow different links. That's not what's happening here. So that one's suspicious. Now, what will we do to run this down? When you want to start running this stuff down, typically what you do is you start looking for what's unique about this that may not be the same as other stuff that's out there. So, for example, when I look at the URL, this looks like a long encoded string to me. So I probably wouldn't have any luck Googling that. The fact that the host parameter was an IP, that might not help me. The Windows 7 user agent string, that might be helpful, but that might turn out to be a legitimate string, in which case it isn't going to be very helpful. The one piece of information I see that looks like it might be unique enough to find out some answers is this directory name right here. So the next thing I would do is start Googling that. Hey, Google, do you have any information on that? And if you run that through Google and start running down what comes back, you'll see that's associated with the Fiesta toolkit. So is this a C2 channel? Yes, it is. It's the Fiesta C2 channel. This is definitely something we need to be concerned about. Let me take a quick look at Discord. Maybe you could add comments and notes or as in text in the presentation. Oh, okay. Yep. That's a good point too. Could definitely go through and do that. Now, it's worth noting that there were 14,000 connections in this data set. There was only one IP talking to one IP that was really something we needed to worry about. We handheld, we talked about this at length, and we still went through this data in a pretty relatively small period of time. So one of the nice things about, Rita and AC Hunter is that it allows you to take all this data and quickly focus in on what you need to pay attention to the most. All right, we're going to do another lab. So let me just import the data with you, and then I'm going to cut you loose, and you need to tell me what's going on in that data set. So we're going to need to go to the lab2 directory. So I'm going to say cd space // lab2. So that says I want the ... says I want to navigate up one directory, and then the /lab2 says I want to navigate back down to the lab2 directory. Once I do, here's my files. I've got a con.log and a dns.log. I wonder what type of interesting information might be in this one. Just a thought. So now I want to import this data. So the way I import data is I say Rita space star.log. I could just say star. I don't know. This just it's I always get nervous with just open wildcards. I always like to put some sort of restriction in there. So I just go in and say star.log. But now we need to name the data set. Lab2, since this is data out of the Lab2 directory. I'm going to go through, hit enter on that. It's going to prompt me for the password. That is hunting. And now Rita will go in and do its thing. Huh? Oh, maybe I got the password wrong. Oh, topic for conduct. What? Oh, you gotta love live demos, right?
Chris, Rita, import.
Oh. Thank you, Bill.
It would never happen to me. Oh, yes, 12 times last week. Yes.
Dude, and I haven't even started drinking yet. This is
exactly.
Bad. So it's Rita space import space star.log space lab2. Thank you, Bill. And now, hey, look, that runs a whole lot better. Awesome. Now, notice it's coming through and it's telling me no proxy data, no TLS or HTTP connections to analyze, no user agent data. So the summary information can do an awful lot to kind of point me in the right direction. So now, if I go back to AC Hunter, I want to go to the dashboard. So again, I want you to do that too. Import that data. Just remember to use the import command like I forgot. Go back to the dashboard, go to settings, and you should now have a Lab 2 data set. Open that up and go through and do an analysis. Now, if you're on the shared instances, your screen will look a little different on this one. You won't have this big red potential C2 over DNS showing up over here. But what you will get is you'll get an IP address listed as a host. And over on the right, you'll see a system with a couple of score points saying potential C2 over DNS. Click on that link, or even better, in either case, go to the DNS module and run from there. So I'm going to give you a little bit to go through this one, and then we will talk about it together. If you're running the VM, your screen will look like this. Notice the big red bold text up here that never showed up before. That is kind of directing you to say, hey, you should probably go take a look at the DNS module. If you're running the online version, you'll see an IP address listed here. You'll see some points have been assigned to potential C2 over DNS. That should also drive you towards this. We changed from the assign it to the system to do it up here, because one of the things you can run into is if I have 3 internal resolvers and they're all resolving something that might be potential C2 over DNS, I don't want to break them out separately. I want to combine that data together. So that's the difference that you're running into between those two versions. Give you a couple more minutes and then we'll talk about this one. Okay, I think we have a little confusion over the online version. So check these out here. So if you're on the VM doing this lab, you'll see this in the top left-hand corner. If you're using the online version, you'll see an IP address listed on the left, and on the right, you'll see this entry here that wasn't that says too many fully qualified domain names per domain with 2074 entries. So this is the way we used to identify potential C2 over DNS. This is what we changed it to just because it stands out more and because we're combining together traffic from multiple DNS servers. So if you're on the online version and you see this, you're good. If you don't see that and you're online, that's okay. That's expected. We're only going to see this on the VM. I'll give you a couple more minutes and then we'll talk about this one. Okay. This one should have been fairly straightforward for you. So like I said, regardless if you're using the online or the VM version, you'll see some indicator telling you got a DNS issue. So that should drive you to the DNS module. So I've got one entry that shows up. I've got a threshold set of 100. We'll come back and talk about that in a little bit. But I've got a threshold set of 100. It says we had 2,074 lookups done, and all of them were for unique resources. That's kind of interesting. But 2,074 resource records were queried for hosts within honestimnotevil.com. Well, the name of the domain is honestimnotevil.com. So clearly it's trustworthy, right? So we're done. This must be okay. Look at the domain name. No. No. So it makes no sense that a domain we've never heard of before would expose 2,074 unique resource records to the internet. So that makes it highly suspicious. I'm also noticing that I have one system doing DNS queries within that domain, but nothing's actually accessing any resources in that domain. Oh, that's really, really, really suspicious. So, yeah, I'm kind of feeling like this might be something I need to be concerned about. Now, I could click on the domain name and do some research on it, but somebody else had kind of pointed this out too. So, one of the things I can do is I can drop my threshold down to 0. And when I do that, I'm going to see everything, including the unique queries that were taking place. So, look at this one. 2F95C2406362B. So, quick show of hands, how many people name their systems this way? Right? That makes no sense. How many people use hex characters to name their systems? Oh, yes, that makes it easier to keep track of, Chris. Because when I see 5DA0B794, I know that's my mail server. What else could it possibly be? No, we don't do that. So looking at these names, that immediately tells me that, yeah, this is not, and I'm down here and I'm just paging through just to kind of look at the additional entries. These all look highly suspect to me. These are definitely not things you would ever name something on purpose as a human. The other thing I'm noticing is that when you look at the characters being used in the name, it's hex. All the characters are either 0 through 9 or A through F. That's hex. Remember, I said one of the things attackers like to do is obfuscate their data? Well, if I took, you know, if I took a name of something and converted it to hex, it doesn't look like that name anymore. It's harder to figure out that's what that name is. If I'm using, network-based intrusion prevention or something along those lines, and I'm trying to do pattern matching to look for bad patterns, well, I'm probably pattern matching on the ASCII. I probably am not going to detect it if this gets converted into hex. So this looks like somebody trying to hide information in these queries that are going out to that system. Oh, that's not good. Now, this system is doing those queries. Is that system the one that's compromised? Maybe, maybe not. It depends upon where my sensor is. So, for example, if Zeke is monitoring the traffic going to my DNS servers, then yes, this is probably my compromised system. But if I'm monitoring traffic where we discussed at the internal interface of the firewall, well, this is just my internal DNS server. Someone is sending it these queries. I need to figure out who that is. Well, how do you find that out, Chris? Well, you got two possibilities. One is I could go to the DNS server and turn on logging. And now I can log who's sending these queries out. But quite honestly, an even easier way to do it, run ngrep. Remember ngrep? We talked about that tool. I can tell ngrep, I want you to monitor UDP port 53. And anytime you see the character string honestimnotevil.com, record that packet. Well, now I'll get to see the source IP address that's sending these queries to my local resolver. That's the IP address that's compromised. That's the one I need to go focus in on. All right, let's see if I missed anything here. Can you decode that? Yes, you can. But that's something I cover in my packet decoding class and the advanced threat hunting class. It's a little bit beyond what we want to get into here. But you can use a tool like CyberChef. There's also some command line tools you can use to take this hex, convert it to ASCII, and figure out what's actually getting passed off on here. But yeah, this looks like C2 over DNS. We have way too many unique resources being queried that is reasonable for a domain that we've never heard of before. We said for a domain we've never heard of, we expect 10 or less. Now, if we saw 12 or 14, I'm not going to freak out about that. If we saw 20, I'm not going to freak out about that. But 2074, oh, that makes absolutely no sense at all. If you drop the threshold, like I said, you can see the actual text that's taking place. We definitely have potential C2 over DNS. Which system is compromised, again, depends upon where this data was collected. The IP address showing up over here might be the system. It's compromised. It might be the resolver. If we're collecting at the firewall, it's the resolver. Now we got to log into this system. And like I said, the way I would do this is I would run ngrep and tell ngrep, hey, anytime you see a payload with honest I'm not evil, log that. And now that would show me what was the source IP address that was actually originating these queries. Now I know what system needs to go in and get cleaned up. It would also tell me, we're assuming there's a compromised system. There might be multiple. There might be more than one. Running ngrep would show us that. All righty. So we're down to our last set of labs. So again, the first thing we need to do is import the data. So this time I am going to remember the import command. Hey, so for all of you that feel like while this stuff's hard and I make mistakes on occasions, I told you, I've been doing this forever. I do Rita in my sleep. I have literally had dreams about Rita and Rita data. I am not making that up. I wish I was. And I forgot to use the import command. So if I can mess this stuff up on occasion, it's okay for you to too. Never feel bad about that. So I'm going to say cd space // lab 3. Navigate up one directory, back down into the lab 3 directory. Now I'm going to go in and take a look at what files are in there. Hey, I got a bunch of them here to work with. And I'm going to say Rita import, very important to include that keyword, star.log, and we'll name it lab3. Hit enter. That imports the data. Once that's done, I can come back over here, go to my dashboard. I can go to settings, but my little gear icon. Now I've got a lab3. Now what I want you to do is go through and hunt that. So I'm going to give you a lot less direction. You got beacons web, you got beacons, you've got long connections. I want you to go through, poke around, and I want you to identify what looks like this is probably okay, we can safe list it, and what looks like, oh, this is going to give us a really bad day/week/month, depending upon how bad it turns out to be. So I'm going to give you a little bit extra time to run through this because I'm giving you a lot less guidance. I'm going to go on mute while you do this lab. Let's take a look at this one. So I'm going to start with long connections and see what's there. And with long connections, we have this one, the port TCP port 9200. That's the one we saw before. That's the one that's associated with the active countermeasures. So that's the one we said, yeah, we need to do a little bit more investigation work to decide whether we can trust that one or not. This one, TCP traffic. Now notice it hasn't been longer than 24 hours yet. So we can see where it was trying to go to. It was trying to go to a Windows notification server. Now, a little bug with the interface in this version, we don't do a digital certificate check on the long connections. We should have been. We missed that. I apologize. But let's assume this had a, we could go back to the Zeke logs to see, did it have a valid digital certificate or not? Let's assume it did. So it's going to Microsoft's environment, going to a Windows notification server. This one's probably okay. So the first one we cleared before, we just didn't make a safe list entry for it. That one looks all right. This one looks all right. So from a long connection perspective, we're in pretty good shape. Next, let's take a look at Beacon Web. So this first one, 3,000 connections going to newbie02. Oh, that doesn't sound like a suspicious host name at all, does it? Noob02? Come on, really? You guys can't come up with better than that when you're attacking us. Going to Skype TM, Skype trademark.com. Yeah, no, that doesn't sound right. No, that's someone registering a domain close to an existing domain. So this one, yeah, this one's looking really suspicious to me. So we'll come back and talk about that one. So let me go to the second one on the list. This is going to self.events.data.microsoft.com. It's a TLS connection. The digital certificate is star.events. The digital certificate is okay. So this looks like calendar stuff within the Microsoft environment. So if we're using that, this is okay. We could create a safe list entry for that one. I take a look at the second one, arc.msn.com. This is going to TCP port 80, or excuse me, TCP 443. It has a valid digital certificate. Now, this one may look at that and say, oh, MSN, that's Microsoft. Yes, it is. But this is used to serve up banner ads. So is this evil? Is this not? This one kind of, it kind of depends on your perspective on this whole thing. It's not really evil, but it's kind of using up bandwidth to serve up banner ads within your Windows environment for the friggin' operating system you paid for. They're still going to pop banner ads up in your face. This is one that I honestly would not safe list, but I would probably add to my firewall so that my systems can't connect to it. because that'll, recover some of that bandwidth and not have banner ads showing up. And quite honestly, we have seen malicious attacks take place over banner ads in the past. So the more we can reduce our users to the exposure of that potential threat vector, the better off we're going to be. So even though this is Microsoft, I wouldn't safe list that. I'd go in and say, oh, hey, let's go in and see if we can filter out traffic to those IPs and deal with it that way instead. So we're back to this first one. So we said that fully qualified domain name it's going to looks really suspicious. Look at this user agent string, Microsoft Internet Explorer. Let's see, would you recommend enterprise-wide ad blockers? Yeah, something you have control of is actually a little bit better than just doing a straight up blanket block, because sometimes there's something you need to get to that now you can't because it's there. And a good ad blocker is going to give you the ability to say, okay, don't trust it completely, but trust it for just this one session. And it gives you a little bit more control. But user agent string, Microsoft Internet Explorer. Oh, come on, you're not even trying, right? Microsoft Internet Explorer identifies itself as IE space the version number. This is definitely bogus. There's no operating system identified here. This user agent string is definitely bogus. Now, if I go under client signatures, I can see that for this IP address, the .54, when it talks to this one system, it says Microsoft Internet Explorer. But look at this, Windows 10, Windows 10, Windows 10. Yeah, we talked about this before. That is a clear indication. Anytime you see somebody manipulating the headers like this, it's probably going to end up being something malicious. Maybe this is C2, maybe not, but there's definitely malware taking place here. Now, when I look at the signaling, yeah, that tells me it's definitely C2. It's going off on a very regular basis, more often than twice a minute. I can see here, notice we got here a bell curve. A couple of you folks picked up on this when you posted into Discord. You said, yeah, Cobalt Strike. Yeah, how did they know it was Cobalt Strike? Because this jitter looks like a bell curve. That tells me it's Cobalt Strike. So it's either, if this ain't evil, this is a red teamer that we hired. And in either case, this is something we definitely want to go in and flag. So notice I didn't really have to go out and research this, right? Like we said, hey, when you click on things, you get all these resources you can use that you can go off and do an investigation on. We didn't need to even do that. There's enough information just in the data stream to look at this and say, oh, yeah, we have a problem. There's something here we really need to be concerned about. Let's see, what else is interesting? So now that we know it's most likely C2, the next thing I want to do is go to view 2 to see, has this been activated? Here's my heartbeat. Here's my, do you have anything for me to do? No, go back to sleep. So it looks like all but 100 and change of these connections have been the heartbeat, right? Because there was 3,188 connections total. 3,052 look like this heartbeat. So the delta between those two, around 135 or so, is going to be how many different points of activation we probably have to deal with. I always jump to the top. I always go look at what's my biggest data transfer, because that's going to kind of scope things, right? If my biggest data transfer is not that big, okay, they're poking and prodding. They haven't stolen anything yet. But if my biggest data transfer is, 5 megs, 10 megs, a gig, 50 gigs, oh, we know we're going to have a really bad day. My biggest data transfer here is 828 bytes. Okay, cool. They haven't stolen the customer database yet. There's no way that's going to fit into 828 bytes. So I've got a C2 connection I need to deal with here. Let's see, did I miss anything? Let's see. So import the logs, do an investigation. We said, yeah, this Skype name, because it's a skype.com.tw is probably legitimate, but Skype TM, that's just somebody hoping you're not going to notice this is not the legitimate domain. The user agent string, we called that out. That looked bogus. the time chart, over 24 hours. There's definitely a repetitive pattern taking place here. It's jittering. This curve looks like cobalt strike. We definitely know this is something we need to worry about. Let's see. Somebody was calling out um, the investigation menu. See, that looks like virus totals. Let's go see what virus total is telling us about this. So yeah, going to virus totals, spyware, malware. Yeah, this is not a legitimate domain. It's associated with malware. And if I look down here, Kitty Tiger. So now I know what malware it is. That's kind of cool. So this definitely tells us we have something bad. So let's see who caught that. Tony. Good job, Tony. Great job. So just a little bit deeper with the investigation menu, and that gives up immediately. Yeah, this is Pity Tiger. This is something we definitely need to be concerned about. And this shows that here as well. So we clearly have an HTTP beacon. Do we have enough data to trigger incident response? I think so. Was there anything else here to worry about? Well, we went through that stuff too. And everything else we looked at looked like, hey, this looks like office traffic. This is probably okay. Also, if you go in, yeah, so let's talk. Oh, yeah, let's take a look at this one. So if we go to DNS, nothing has 100 or more. Great. Let's drop down to 0 just to kind of look at what was there. Somebody flagged this and another entry that was similar to that. This stuff. What is this? Is this C2 over DNS? See this top level domain, ARPA? That is a reserved domain. No one can register it. We call it ARPA. What this is this is used for reverse lookups only. So anytime you see a query going to the ARPA domain, what that means is, hey, I have a fully qualified domain name, and I have an IP address, and I want to see what fully qualified domain name is associated with that. And it's weird because it prints the addresses out backwards. So this is an ARPA query. So ARPA means reverse lookup. This is IPv6 versus IPv4. And then these are my bytes in reverse order, right? The lookup is always backwards. Let's see if I can't find an IPv4 lookup because those are a little bit easier to read. Yeah, I'm not seeing one right away. If you look at a reverse lookup that's going to that's an IPv4 lookup, those are a little bit cleaner and easier to read. But you get the idea. This is just a reverse lookup. I have an IP. I want to see if there's a host name associated with it. That's the type of query taking place. This one's okay. We didn't need to worry about that. The other one that was getting flagged was an OpenDNS one. Let me just find that real quick. Here. Surprised this didn't show up under DNS. So OpenDNS has a service where they will look to see, is the domain name you're querying known to be evil? The usefulness of this to me is kind of minimal because, again, it's not about mass propagation anymore. It's about targeted attacks. So the IPs, the domain names, the infrastructure, the malware, usually that gets customized against you. But, you got to use DNS servers. It's kind of better than nothing. But the way it works is you forward all your DNS queries to them, and they either send you back the right answer if it looks like it's safe, or send you back an answer that won't let you get to that site if it looks like it's not. So that's the service that's taking place here. And this will show up on the DNS screen on occasion too. If you have a busy environment doing a lot of lookups through OpenDNS, you'll see this show up as, hey, you're resolving a lot of resources in that domain and nobody is going to it. It looks pretty much exactly like C2 over DNS. But because it's OpenDNS, oh yeah, no, we're just using this for our queries. Okay, what else we got here? Talked about the long connections. If you want to keep practicing, one of the things we do is this thing called malware of the day. So if you go up to our blog, do a search on malware of the day, Keith maintains this. There's a best practice for going through these entries. if you want to use this for practice, go to the blog entry and very quickly skip to the very bottom. Don't read the top, because at the very bottom, Keith posts the PCAPs that he worked with in order to create that blog write-up. So download that PCAP, go in and do an analysis. Can you see what looks like potential C2? What attributes do you identify that helps you figure out that this is something malicious? Okay, now go back and read Keith's write-up. Did you miss anything? If you did, like maybe you missed the user agent string looks wrong. Okay, now you know you need to modify your process in a way that will incorporate checking that data point. If you're interested in a demo in the enterprise version or you just want to talk about it, feel free to type demo into the Zoom chat. Please not Discord, because this is just a lot of Discord and it's really easy to miss it. But if you go back to the Zoom chat and type it in there, or just drop an email to questions@activecountermeasures.com, we're happy to give you a run through it. And hey, that's it for the hard sell on the commercial version. Closing thoughts. Remember our process here. Look for connection persistency. When you find it, look to see, is there a business reason why this connection might be taking place? If not, deep dive on the external IP, deep dive on the protocol, deep dive on the internal system. Try to see, can I recognize a business need for this? If not, it's time to go in and to do an incident response. And as a threat hunter, our job is for everything connected to the endpoint, not just our desktops, not just our servers, everything connected to the desktop, printers included, IoT included. Is it still pristine? Is it potentially in a compromised state? It's what's referred to as a compromise assessment. So every time we do a threat hunt, we're doing a compromise assessment. We're assessing our whole network to see, is there any potential compromises we need to go after? And with that, I've got some classes coming up. You can kind of decide what you want to check out, what you don't. Let's see what else. And thank you for attending. So that's it. That's it for that stuff. Now, we're done. So if you want to drop, please feel free. Thank you for joining in with us today. I know it's a free class, but it's not. You just gave up 6 hours of your life. You gave up 6 hours of your life to spend with us. That has value. So that makes this, even though you may not have, paid US dollars or whatever, that means this class still has a value to it. And the fact that you were willing to spend your time with us really means a lot to all of us. So again, just wanted to say thank you for folks spending some time with us today. Now, if you want to drop, feel free. If you want to stick around, I talked about, I would go through and kind of show you where we're going with the product. So that's what we're going to do now. So there's no more like useful content. You could argue this is all just like ad shit now because, oh, I didn't say that word over the system. Sorry about that. But yeah, you get the idea. At this point, I'm just going to kind of talk through what's going on here. So one of the things we're changing is we're changing the way the hunt actually flows, right? Historically, we've gone in and we've scored things based on system. What we kind of learned over that time period was that, well, that seems to make logical sense. One of the challenges you run into is sometimes things that are not associated to a compromise can add to the score and make a system look worse than it actually is. So what we decided to do is to change from targeting systems to targeting connection sessions. That kind of makes sense. If you think about what we just did as we went through in hunting, we were kind of focused on the sessions. Hey, communications going to this looks bad. Communications to this look okay. So we decided to go through and break it up that way. We've tried to, so this is where things kind of get weird, right? So I'm the product owner for AC Hunter. I'm the one who kind of drives where this thing's going to go. The job of most product developers is to get you to spend as much time in their tool as possible, right? You can't use Facebook or X or anything these days without telling me they're not trying to get you to stay in that app as long as they possibly can. My job is the opposite of that. My job is to let you find what you need and get out of this tool as quickly as possible. We have no delusions that, oh, look how pretty this is. I want to leave it up all the time. This is art. You want to state, no, you have a job to do, right? And if you get an alert saying, hey, I think 192.168.1.50 might now be in a compromised state, you need to figure that out as quickly as possible. And if it's compromised, you need enough data to be able to run it down to run it to ground. If it turns out that it's not in a compromised state, you need to figure that out again as quickly as possible so you can jump out and get other work done. Because none of us get to do just this. So we've tried to change this interface to optimize the minimal amount of time you'll have to spend in our tool, if that makes any sense at all. But notice we're going through kind of similar to what we were just talking about, source destination. Now, one of the things we're doing is we're using some icons to kind of cue you in on what's interesting about this. These icons are going to change, right? Like this one's beacon. Well, no, that's a Wi-Fi beacon. That's not what we're supposed to be talking about here. So the icons are going to get changed up. These are just placeholders for now. But we're going to start color coding things. So, for example, the fact that this went to DigitalOcean, it's highlighting it in red. We're not scoring it higher because of that. But what we are going to tell you is, hey, when you go through all the ASNs that are out on the internet and you look at what are the top 10 where attacks are originating from, and what are the bottom 10 that attacks are originating from, anything in the top 10 gets coded in red. Anything from the bottom 10 gets coded in green. So you have a little bit of guidance to help you kind of figure things out. Don't read the details. If you just pull back and look at the colors tell you, I need to worry about these. These are probably okay. So again, we're trying to optimize your ability to go through and do this. We've got some protocol information. This is something new we're going to start doing. First seen in prevalence. What's this? So first seen is just simply, when was the first time any of your systems talked to this host out on the internet? Because that kind of matters. If I tell you that your hosts have been communicating with this host on the internet for the last 90 days, oh, okay. Yeah, that's probably right. If I tell you, hey, this is the first time anyone's talked to it over the last 90 days, this is the first time anybody's talked to it, and it's been within the last hour. Oh, that's greenfield, right? That's something brand new. That's something that is going to immediately draw my eye to. I need to go in and kind of run this down. Prevalence is how many of your systems are talking to this. So again, if you see that first seen was more than 90 days ago, prevalence is 95% of your network is talking to this. No, this is probably fine. Either my whole network is compromised or I'm okay, and I'm probably okay. But again, if it's, hey, it first showed up 7 hours ago, and this is the only system that's ever talked to this system, oh, that's bad. That's something I want to make sure I go in and I run down quickly. The other thing we're going to start doing is we're going to start giving you things like tags. So you can go through and you can organize these. Hey, these systems are, these C-level suites. We want to, handle those a little bit differently. These systems are part of not part of the corporate office, they're part of a field office. So we want to tag those a little bit differently. So you'll have tags to be able to work with. You'll also be able to do things like create tags that say needs further review. So now I can go to Bill and say, hey, Bill, I did a hunt. I had a couple I'm not sure about. Can you go back and check them? I tagged them all, needs further review. Now he can go in and filter on that and just focus in on the ones that he needs to worry about. And that's it. We can also, you can also add notes. So if I saw something suspicious, I can tag it needs further review. I can make some notes about what I saw. So now when Bill goes in and reviews it, he can see my notes and he can edit and he can add to them. He can do whatever he wants to them. We're also starting to add in hints. So hints are for things that don't belong on the safe list, but we want to give you some additional information to make sure you make good choices. For example, TeamViewer, right? TeamViewer is one that we want to talk to you about and say, hey, this is remote access software. This can be dangerous, but if you know it's there, it's okay. If you didn't expect it to be there, go figure out why very quickly. Hey, this is a content delivery network. You absolutely don't want to create a safe list entry based on IP address. If you got to create safe list entries, they got to be based on fully qualified domain names so you can sort between the good traffic and the bad traffic. And then action, what do you want to do with this? Do you want to create a JIRA ticket and jump this in immediately in an incident response? Do you want to create a safe list entry for it? What is it you want to do? What do you want to do to make this, disappear off the screen, so to speak, type of thing? That's just the main screen. Now, I might also decide, okay, I'm suspicious, but I don't have enough to really let me know this is something I need to worry about. Well, you could click on the entry, and that'll bring you into information like this. So now we'll go through and we'll drill in on excuse me. Now we'll drill in on what was wrong with this. What did we see? What are those graphs that just showed up for beacon traffic? They're going to show up for everything now. So, like a long connection, you'll get to see that. You'll get to see what data is getting transferred and when, type of thing. We'll also go through and start giving you summaries on what type of communications are taking place to that box. So, for example, you might see a ton of connections going to that system, but this may come back and tell you, oh, those connections are getting reset. Well, now I know, okay, that's not a beacon. That's software trying to talk to a server, but the server is offline. And that's why it keeps connecting like that, because it can't connect to the server. The server is offline. This will help you diagnose problems like that. It'll also help you run down things like, we were talking about like the Windows 10 versus Windows 7 thing. We've got views in here for you to be able to see that. We also have views to be able to show you what data is being requested. That's something we don't show you in AC Hunter today. We show you the host parameter and we show you the user agent, but we don't show you what data they're actually trying to get. Now we're going to start showing you that. We're also going to call out things like the MIME type. One of the common techniques you see with C2 channels is it will be you're downloading a JPEG file, but the server will tell you, hey, that's a text file. What? Yeah, it's a text file. Handle it like a text file. Why would it do that? Well, because by identifying it as a text file, it can now embed executable commands inside of it and get the client system to execute those commands. But when you see the URL, you say, oh, they're just looking at a JPEG file. That's no big deal. Because you might miss the fact that the MIME type is mismatched. We'll actually start calling stuff like that out for you. So traffic light colors aren't useful. Yeah, as Bill was saying, so one of the things we've done is there are a bunch of different shadings in here. So we've gone in and we've looked at what are some of the visual challenges that people run into, right? Like, when you talk about like color blindness, it's not exactly the same for everybody. Some people, it's one color versus another. So we've actually gone through and come up with a couple of different themes based on what people might be running into to be able to change the way this whole thing gets viewed. Long term, we want to be able to give you some ability to edit the colors yourself. But I'm going to be honest and say that won't be there in the first version. And that's it. So this is where we're going. You're going to see a new version of Rita come out probably over the next couple of months that has all of the back end changes incorporated that we're making right now. I mentioned earlier we're changing up the back end database so things run much faster. Rita will include features like this first scene and prevalence and stuff like that, but it's all going to be command line based. So once you see we've updated Rita, the AC Hunter, Community Edition and Enterprise updates are not too far behind that. Could you add an option to change the font? Yep, that's part. So that won't be there in the next version. But as far as being able to customize these profiles and make it the way you want, that will be one of the options is you can change up the fonts. So if you want everything to show up in Wingding, you can do that if you really want to, or some Linux equivalent of that. Cool. With that said, hey, we're done. So I appreciate, wow, so many folks hanging out late on a Friday to kind of, look at my little baby and what I'm proud of here. I'm just super excited on where we're going with this whole thing. But I appreciate folks hanging out to kind of talk about that. So with that said, we are done. You'll see this get posted to YouTube probably over the next 24 hours. And like I said, give it a good 24 hours before you worry about whether you got your certificate for the class or not. If you don't have a certificate by Monday, drop us an email and we'll go through and take care of you. So, but with that said, hey, we are done. So, other folks, Bill, Ryan, if you're still around, anybody got anything else they want to add?
I don't have anything to add, but that was awesome, Chris. Thank you.
No worries.
And such a great community too. I mean, all the conversations and all the technical talks and Discord, this was awesome.
We appreciate your time and all the good input. Thank you so much, everybody.
Yeah.
Thanks, Bill. Thanks, Keith. Thanks, Chris, Ryan. Awesome job and great community. It was fun.
Yeah. So two things real quick. One was somebody asked about certificates again. So certificates usually go out within about 24 hours. So what I would ask is wait till Monday morning because, hey, hopefully you're not working over the weekend anyway. If Monday morning you don't have your certificate to the email address that you registered with, drop us an email and we'll go through and we'll help you out with that. Also, folks were folks were talking about community. I agree. One of the things that I love that we have here is that the closest thing we had to people responding to folks, and not giving a straight answer was, go read the FAQ. We're really big on everybody starts learning somewhere. Everybody starts this journey at a point where they don't know crap. And I will admit, I was definitely one of them at one point in my life.
I'm still there, Chris. I'm still there.
Me too.
So we're really big on being helpful to each other. One of the things I absolutely love is you get folks like, Discordless that shows up, for each of these. And they've gone through the content. They know it. They're just here to help out other folks. They've gone through the VM problems already, and they know that sometimes, like Bill and Keith get sidetracked helping one person and they jump in and help out other folks. And I just have to say, as a community, oh my God, you guys rock. And that's part of the reason why we keep doing this. So,
and totally agree. And it's refreshing to see people sharing information instead of like holding it, to their chest. And,
yes, exactly.
I'm the greatest because I have the info. No.
Yeah.
You need to share it so we can all defend ourselves. So it's awesome.
Yes. I am He-Man. I have the knowledge.
Yeah.
Oh, wait. I think I have a sword for that.
Well, I'm sure you do. And I'm sure it's within arm's reach, right?
Yes, it is. Well, no, actually, I'd have to take the headset off to reach it. So it's just barely out of arm's reach, right next to the didgeridoo.
Well, I do want to do a shout out to I said, all right, this is my 20th time taking the class and I learned 2 more new things today.
So, wow.
Holy shoot. We've done this class at least 20 times. Wow.
Have we done it already 20 times?
That is awesome.
Well, thank you for coming back and thank you for keeping track. I had no idea how many of these we've done. So
here's to 21.
Yes.
That's both an awesome achievement and a little bit of sympathy, I guess, right?
Yeah, I'll have to have Shelby go through and add up how many folks have gone through this class. The last time I checked, and it was probably a year ago, we were over 30,000. Yeah, so I would be interested to see kind of where we're at right now. So
yeah, that's the last I saw too. It was above 30 grand. So.
Yeah. Fun. All right. Well, I've got to go feed my wife Chinese food before I get in trouble. So
good. Thanks, guys.
Yeah. Thanks. Everybody have a great weekend.
Thanks.
Bye-bye.
Bye-bye, folks.
Bye.
Bye-bye.